sharing the knowledge and for the innovation. I would like to say that AfricaBP cannot miss this opportunity. What I mean by this opportunity is the fourth revolution, which is genomics. This fourth revolution, powered by genomics and artificial intelligence, it's not an option for Africa. It's a necessity because it holds in it the chance and the power to answer our challenges or the challenges that plagued us for generations. What I mean by these challenges is hunger, diseases, and environmental degradation. By mastering genomics, we can unlock biodiversity full potential. We can conserve and protect our ecosystems, and we can ensure that every African child have access to food and healthcare. But let's say that this revolution demands more than technology and sequencing and science. It demands leadership. It demands that Africa speaks with one voice, sets its own agenda, and builds systems that works for Africans by Africans. For centuries, independents have spoken in political terms. But in reality, independence of countries is a matter of intellectual, ideological, and economic self-determination. Africa must own its narrative, data, and scientific discoveries. We must be the author of our destiny, shaping a future where Africa's resource, either natural, intellectual, or genetic, are harnessed for the benefit of its population. This is where the AfricaBP, our project, stands as a shining example, because through AfricaBP, we are providing examples that Africa can unite through borders, share knowledge, and create solutions tailored to our problems. This initiative is not just a project and scientific project. It's a symbol of Africa's capacity to take charge of its destiny. It's a powerful demonstration of how genomics can be the foundation of independence. AfricaBP shows and is showing how much we can achieve when we come together for shared objective and shared goals. It highlights the power of genomics and science in general to open the door to a more developed Africa. But Africa that is not only advancing in science, but embracing its identity. By creating platforms like this project and workshop, AfricaBP equips scientists with the tools and the networks needed to lead global discussion on genomics and bioeconomy, ensuring that Africa takes its rightful place for the future of science and innovation within our continent. To conclude, let me express my deepest gratitude to the organizing and scientific committees, to our partners and sponsors, to each one of you for your commitment for this vision, the vision of a more advanced and developed Africa. As we embark on these discussions and practical session, let's us remember Africa's story is still being written and we are its authors. Thank you, and let's make this week a great one. Thank you. Now it's my great honor to present our Dean, whose commitment and support was instrumental for this workshop. Please let us welcome Professor Mohammed Regragui to share his opening remarks.
Thank you, Professor Badawi. You said that all that you prepare for me. Then I have just to welcome you. It's my honor and privilege to welcome you at the African BP workshop 2024 and held here in our university. And thank you also for being here and for the commitment to this important cause. I wish you a productive, inspiring, and unforgettable workshop. Let's make it a success for Africa, for science, and for future. Thank you.
Thank you very much, Professor Regragui. So now I have really privilege to introduce Professor Anne Mugai, which is a distinguished molecular population genetics geneticist with a deep passion for indigenous African animal species. Prof. Mugai currently serves as the Deputy Vice Chancellor of the National Defense University, Kenya, and she is in her second term as a member of Bioethics Council. She is also the chair of AfricaBP, an ambitious and transformative initiative aiming to characterize and sequence 100,000 species through the continent within a decade. Prof. Mugai's leadership and dedication to advancing science for the benefit of Africa make her a truly inspiring figure. Please join me in welcoming Professor Anne Mugai.
Thank you very, very much, Professor Bouabid, for your introduction. And I'd also like to thank the entire committee, the entire leadership of Mohammed V University for the invitation to make this presentation here today. I also want to acknowledge the hard work that has been done by the local organizing committee to be able to organize this workshop for the second year running, and this is really commendable. My role here today is to explain to you where we are at with the African BioGenome Project, and also share with you some of our thoughts, our vision, and our highlights. I make this presentation on behalf of the entire steering committee, of which I am privileged and humbled to be the chair. So this is the highlight of my presentation today. And hopefully at the end of it, I will be able to share our vision, and perhaps you will also be able to join us on this very, very great venture of sequencing 100,000 genomes within 10 years. So the AfricaBP was conceptualized in 2019. Before 2019, we were laying the work and laying the foundation for the project, and we officially launched it in June of 2021. And in March of 2022, we published our vision in a concept paper that was published in Nature on the 15th of March of 2022. This particular publication was received very, very well by the entire international community, where it was featured in more than 300 news outlets with a lot of excitement for the fact that Africans had gotten together to actually sequence their own genomes. This was overwhelmingly well received, and it gave us a lot of motivation to continue with our vision. So the goals of the African BioGenome Project, as we outlined in that paper, is to, first of all, coordinate all non-human genome sequencing initiatives, those that are existing or will be emerging in Africa. And we're focusing on the non-human genome initiatives because the human genome sequencing efforts in Africa were very well coordinated. We also wanted to act as a forum for discussions around the non-human genome sequencing of species. We also want to be able to initiate, develop, and support any new non-human genome sequencing efforts so that the reference genomes that are sequenced can actually be part and parcel of the African BioGenome Project. And as I outlined, our goal is to sequence more than 105,000 species that are indigenous endemic to Africa. We don't want to just do that without deploying the sequencing data to contribute effectively to answer questions, research questions, biodiversity questions, questions about conservation, and also to inform the policy space within the African continent. Our project, as I mentioned, will cover all eukaryotic lineages. So plants, animals, eukaryotic species that are important, that are endemic, that are at risk, that are nominated by Africans who feel that these species are important. So we have species that we have identified, and these are continuously being updated depending on the developments that are happening within the particular region. What do we envisage? We envisage to build collaborations and build capacities across the African continent. As we began working, we realized that collaborations between African scientists and scientists based in other parts of the world outside Africa were very strong. But within Africa, ourselves, we were not collaborating as strongly. And therefore, we see that this project will provide that and is providing that forum where we'll have within Africa collaborations happening. We also want to build capacities of young early career scientists who will be able to carry this vision forward. And we also want to ensure that we as Africans contribute reference genomes to the African databases. And using this information, we want to drive policy. Anything that we see that needs to be written up and taken up by a national government, we want to be able to be at the table where these conversations are actually happening. So the African BP timeline, as you will see, we began in 2021 with an inauguration meeting. And then we continued our consultations. So between 2022 and March of this year, we had commenced our pilot project. This pilot project was key because the workflows and the sequences and the protocols that would be used in sampling were put down, tested, and actually used. And therefore now we have systems that are ready and operationalized and working. So between April 2022 to March of 2028, the next 4 years, we will now begin to actively sequence our genomes. And hopefully by the end of 10 years, we will be speaking of at least more than 100,000 genomes. Our goal is to sequence 95% of the AfricaBP genomes in African institutions in Africa. Of course, when we began, the questions that were asked is, do you have the infrastructure? Do you have the people? Do you know how to do this? But I think with the completion of the pilot project, we've been able to show that we have African institutions, we have African infrastructure, and we're now building the capacity through efforts such as this, through the workshops, to be able to train African scientists to be able to do that. To do this, we will generate an estimated 203,000 gigabases of DNA sequences, and the aim is to analyze all this on the continent. However, we have realized that we have infrastructural gaps, we have genomics and bioinformatics capacity gaps, meaning that we don't have enough bioinformaticians and genomic scientists on the ground to be able to handle this large amount of data. Therefore, the African BioGenome regional workshops is an effort towards bridging this gap and to ensure that when this data begins getting generated, we will have a proper infrastructure in place, and we will also have the young scientists and the other scientists being able to analyze this data. The AfricaBP workshops are very unique because they're openly accessible workshops. One of the reasons why perhaps we've not been able to train African scientists effectively is because there are certain barriers, barriers around access. And therefore, to address this, we have made these workshops completely accessible by having blended participation meaning that some people attend virtually and some people attend in person. They are hosted by African institutions. Again, this also ensures that we have accessibility of participants to the workshops. And through these regional workshops, African institutions are getting to collaborate and drive these processes together. As I will show you, we have all the regions of Africa now being coordinated through 5 regional nodes to hold these workshops. And therefore, we are starting to see concentration of institutions, scientists, and young scientists working together in this area of genomics and bioinformatics. Therefore, these workshops present us with an opportunity for training Africans in this area of genomics, bioinformatics, sampling and legislation. And we are now looking at ways in which this can be stepped up, because we've now done this for 2 years. So let me share some highlights of the AfricaBP project as we go along. The first was the institution of the AfricaBP Open Institute for Genomics and Bioinformatics. You could say that this is our training arm. This is the challenge or the arm of AfricaBP that allows us to be able to go out and do this capacity building for Africans. And to do this, we published our vision and our position paper on training in 2023, where we outlined all our vision within that. And then 1 year later, we actually published the results of the 2023 workshops that had been held. So first we said, this is what we are outlining to do. We went out, we did it, and then we published a paper saying what our successes are, what our lessons were, and what our vision going forward is. So this is one of the highlights that we're very pleased to be able to share with you. So we held 4 regional workshops in 2023, the one that went out in our publication, where we registered more than 3,000 participants who were present physically or virtually. In each of these workshops, we had availability for practical workshops. And during this practical hands-on training, we trained more than 350 participants for it. For these 350 participants who were invited to attend the workshop physically, we had 4,000 applications for them. So you see the demand for having hands-on practical training is very, very high. And yet we're just able to scratch the surface because of infrastructure that is already in place. So these were the 4 workshops held in Nigeria in May of 2023, held in South Africa in August of 2023, held in North Africa, in Morocco in October of 2023, and in East and Central Africa in December of 2023. So the conference follows 2 days of conference-style presentations. Like what's going to happen now in North Africa, we'll have 2 days where we get experts, we get scientists to come and share their insights to all the participants who have registered in person and in virtually. And as you can see, we were able to follow this model throughout the 4 regions of Africa. So the East Africa workshop was hosted in Nairobi, but it also carries Central Africa. So the East Africa workshop covers East Africa and Central Africa. And then we have South Africa, we have West Africa and North Africa, and that's how the 5 regions of Africa are covered. So following the 2 days of conference-style presentations, we have 3 days hands-on practical training, where we train early career scientists on hands-on genomics and bioinformatics. And you can see in this slide here, we have the practical training that was done in South Africa at AfricaBP Biotech. We have the practical training that was done in separations in South Africa. And here we have examples of some of the workshops that were held in Northern Africa last year. This was the practical that was held in Central Africa. So the in-person workshop was held in Nairobi, but we were able to host practicals in University of Yaoundé 1 and also the University of Kinshasa, which are found in Central Africa. And we're very, very happy to have this effort going on. As was quoted by the Dean of the Faculty of Science of Mohammed V University, hosting the AfricaBP Open Institute Regional Workshop is not just an honor for Mohammed V University in Rabat, but a solemn responsibility for Africa. This quotation resounds very strongly with us, because we see African institutions being the driver for capacity building, not only for bioinformatics, but for genomics, and also for providing jobs for these young early career scientists and providing them an opportunity. So we really, really appreciate this vision that has been cited by Professor Mohammed. At the end of the two-day practical workshop and the two-day in-conference style presentations and the three-day practical workshop, each participant gets a certificate, and these certificates say that you have attended a two-day in-conference style workshop or three-day practical workshop, and the exact practical workshop is listed on the certificate. I must mention here that these certificates have been able to open doors for many of our young scientists to be able to move on to either a master's or a postdoc or another, because at least it shows that they have skills that are necessary for their career going forward. So these are examples of some of the workshop certificates we produced from North Africa and East Africa in 2023. So what is unique about the AfricaBP workshops? Like I've said, they're accessible, they're open, they're held in collaboration with African institutions across Africa. And this is really, really key, because African institutions that are present have invested in infrastructure that should be fully utilized. And this is one way that we're ensuring that this infrastructure is effectively also utilized. So we have some highlights on sequenced genomes, and we're very, very proud to share that we have now sequenced up to 22 African genomes on the continent. This is significant because we have been able to develop the pipelines, and we have been able to produce whole genome sequencing from the long-read sequencing platforms, and all this has been done on the African continent. So what we're showing is that these sequencing efforts need not be done elsewhere. They should be and can be done on the African continent. So we have genes that have been done and sponsored by UNISA. We have those that have been sponsored by VGP, and those have been sponsored by SAMRC. This slide shows that we've been able to provide high quality genomes with great coverage, equal and same as those that have been produced outside. I mentioned some sequences that have been paid for by VGP, Vertebrate Genome Project, and these are just the first three, and the others that are on the pipeline. And this was sequenced by SAMRC, that's the Hylicrium plant species. And this is the beginning of a plant effort that will be very, very effectively utilized in 2025. So what was envisaged for 2024? The year is coming to the end. The North Africa workshop that is currently going on is the last in a series of workshops that we had envisaged for 2024. So we held a workshop in West Africa in May of 2024. We held the East and Central Africa joint workshop on the first week of August of 2024. We held the South Africa workshop in September, and we're so proud to see North Africa now holding their workshop in November. So again, these lessons learned, because there are always lessons learned, the positives, the challenges that were experienced will be put up and prepared in the form of a manuscript, which we hope to publish in 2025. The other effort that we have is that we are training Africa early career scientists beyond the regional workshop. And again, here I show a fellowship that was done jointly between the Biodiversity Genomics 2024 workshop, between AfricaBP Open Institute and the African Genome Center. So we shortlisted 10 career scientists, early career scientists from different regions. This was completely competitive. We were hoping that we would get African scientists from across Africa, which we did. They flown to Mohammed VI Polytechnic with the aim of sequencing AfricaBP genomes, and this effectively contributed to the genomes that AfricaBP will be publishing in 2025. We also established the AfricaBP Fellow for Genomic Leaders for 2024. This is an initiative that we will continue. This is also a way in which we will have the post-regional workshop training happening. This particular workshop fellowship was done in partnership with Carl R. Woese Institute for Genomics, based in the University of Illinois in the USA. And here we put out an advert, put out a call, got African scientists to apply for it. And we got 4 candidates who were selected. So the idea is that they will spend 4 months in the USA. They're currently spending the 4 months in the USA, and then they'll come back and they'll be hosted by an African institution. And again, the sequencing effort for African genomes will continue. So I'm very, very proud to present to you the 4 African scientists, as you can see from my extreme right, including scientists from North Africa, West Africa, and East Africa. So they went to Illinois, USA in September, and they're currently going on with their training there. So here again, we are very proud that they are not only doing scientific studies, but they are also being able to network. And here they're pictured with the editor-in-chief of Nature, Magdalena Skipper. And this is an opportunity that AfricaBP is very, very proud to have been able to highlight. And as you can see, we are very proud of these scientists. So I'd like to leave you with some food for thought. One of the things is that African scientists have been very quick to sequence genomes outside Africa, meaning that they would isolate their samples and then send them somewhere in Europe or America or Asia. But we have been able to show that we can sequence high-quality genomes in Africa. So sequencing off-continent serves as a short-term goal. It's cheap, but it negates a long-term goal. That means that we are never able to build the infrastructure on the continent, and we're not able to build capacity on the continent. And like my co-chair, Dr. Thangod Ebenezer says, how many scientists send samples abroad and are not proud of it? How many scientists put their short-term personal gains before the long-term African gain? So how many scientists complain about limited capacity in Africa, yet fail to lay the foundation for the future? So by not sequencing on the continent, we actually shoot ourselves in the foot. So AfricaBP is very, very keen to ensure that we will sequence many, if not all, of the African samples that we collect on the continent, because this will eventually be able to lead to a sustainable development of infrastructure and capacity on the continent. We also need to ensure that the early career scientists that we're training, who will be there working in this area after us, comes hand in hand with mechanisms of retaining them on the continent, which means that when we finish the training, they need to get jobs, good jobs, well-paying jobs in African institutions that allows them to be able to live on the continent. Otherwise, they will pack up and leave the continent and look for so-called better jobs out there. So to do that, we need good infrastructure. We also need good, well-paying positions and providing them with opportunities for promotion, growth, and development. So the important role of AfricaBP in this space cannot be reiterated. We have to bridge the capacity gaps of African scientists on the continent. We have to be able to discuss the capacity building and training needs of our scientists, and we have to be able to discuss curricula that can be developed for bachelor's programs that can be used to address this need. And I wish to thank you all for your attention and invite you to visit our website, where you'll be able to catch up with all the news that we have. Thank you so much for this opportunity. I thank you.
Thank you very much, Professor Anmuge, for this insightful presentation showing substantial impact of AfricaBP project, either scientific or capacity building impact. Thank you very much. Your endeavor for the AfricaBP is really much appreciated and is fundamental for the project. In the same context, I would like to mention that here in the country, in the context of AfricaBP, we are starting a serious discussion with the responsibles about 1,000 Moroccan genomes, to sequence 1,000 Moroccan genomes mainly including species with high economical impact, including plants and animals. And we believe that this initiative could change the game on the country, either from the agriculture point of view or from the point of capacity building and training in the country. And our institutions, Faculty of Science here, supports completely this initiative. And our Dean, Professor Mohammed Wagagi, with the discussion with him, he is fully supporting this. So hope for the best for this initiative. If you have any questions, or because now we have to take a break, coffee break, and come back to start the conferences. Photo? Yes. So please, what we will do, we will take a photo group for, there's a question there, please. Just we will take one questions and we go to take photo and the coffee break.
So thank you very much. First of all, I would like to thank you for your presentation, Doctor. So I'm going straight to my question, my proposition, or my idea is, can we have this kind of, because we are going to generate a lot of data of sequence. So can we have this kind of platform that will gather all this sequence in order to be like free access for all the people in Africa, and we can also add some protocol for some sequencing in order to be something very easier to all the people in Africa. And thank you.
Thank you very much for your questions. Yes, of course. I mean, the slogan of this project is producing by African for Africans. So we are internally, we are discussing many of the procedure, how to store the data, how to make them accessible for the African scientists that would like to do works in that. So yes, this is the main strategy and the main slogan of the project. All is open in this project and is for the interest of the continent. Thank you. So what we will do now, we will have a photo for all of us and have a coffee break and come back for the starting of the conferences. So please join me for the photo. Thank you. Please come near here for the photo.
Okay.
هذا يقدر يكون تما مع كنزه ولا هذا ديك السي ماشي ديال الاستاذ العظيم كتخلي تليفون صافي وين معك الصوت العظيم مازال كوفي بالك اجل مازال عندنا كوفي بالك انت كي داير ها كتوجدي
première, deuxième, البريمير جونفي 2023 date d'entrée, c'est la date du huit ans ما جابولناش في 40% هذوك الباسبور اوتوماتيكمون date d'entrée la date ديال دابا هما
اللي كانوا قالوا دابا خلي ما خصش كلشي لي بور تريتي pas les traiter d'avant. La chose est là. Ouais, tout à fait, tout à fait.
أنا شو هذا الكلام
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer mechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
I think we should start. Please have a seat. Thank you. Well, dear guests, students and colleagues, good morning, everyone, and welcome to the African BP workshop. This workshop is designed to be interactive and collaborative. This is why we, again, are going to have the 3 last days as a practical ones. So I encourage you to engage fully, ask questions, and share insights, and think boldly about the possibilities ahead. Together, we can explore innovative solutions that bridge science, technology, and sustainable development. It's a pleasure to moderate the first session of this week, the first session on innovation for sustainable future, genomics, connectivity, and bioeconomy. Today, we'll delve into how these transformative fields can drive sustainability and help tackle global challenges. This session is an opportunity to explore the cutting-edge advancements in genomics, the power of digital connectivity, and the principle of the bioeconomy are converging to address some of these most pressing global challenges, as was said by the chair of the workshop, Professor Bouabid Badawi. We're fortunate to have an exceptional lineup of experts who will share their insights, innovations, and visions for the future where science and sustainability work hand in hand. Let's get started by our first speaker, Dr. Elsa Chatut. She's an expert in environmental governance, biodiversity, conservation, and sustainable development with over 28 years of interdisciplinary experience in international, regional, and national projects. Currently, she serves as the for sciences at the UNESCO Office for the Maghreb, where she leads initiatives on ecology, earth sciences, and resilience in socio-ecological systems. Well, through her career, Dr. Chatut has collaborated with renewed organizations, the IUCN and UNEP and the World Bank, as well as governmental and private sector entities. She will talk today about the landscape connectivity, a multidisciplinary, multidimensional approach for the Maghreb region. The floor is yours, Dr. Elsa.
Good morning, everyone. I'll speak in English. This is better. Okay. So this is better. First, I would like to thank Dr. Badawi and for sure the Dean of the Faculty of Science at the University, Dr. Berghedi, and Dr. Lina Tazi for giving me the opportunity to join this conference. Today what I will do, I will present, I will not talk about genomics in terms of genes and gene sequencing, but I will invite you to know more about UNESCO's work in terms of biodiversity conservation and how we can link the bioprospection to the UNESCO designated sites, and how also we can connect landscapes in terms of landscapes at all levels when we talk about biodiversity. So I will start just to give a briefing about biodiversity. Very, very briefly, I will go through this. I will show you what we have in Africa, and then I will focus on the Maghreb region. But in fact, when we talk about landscape connectivity, we cannot just be limited to talk about one region. Landscape connectivity, it's large scales initiatives where we have to consider many ecosystems, linking them together. Before I start, I would like just to ask a question, just to make it a little bit, not informal, but a little bit interactive. We have a lot of youth here, and I'm happy to see a lot of youth joining this conference. because we have the map use program, in fact, at UNESCO, and we're now mobilizing efforts to create the Arab Map Use Forum and the Arab Map Use Network, in fact, and Maghreb is part of this network. I have 30 minutes or 20? Oh, okay, so I have to move very fast. So please, can you okay. Next, please. Next.
This is to go forward and
Okay. Wait. Shall I put here or? Where is it moved? Okay. Okay. So as we can see, when we talk about biodiversity level and landscape connectivity, I'm talking about landscape in terms of biodiversity, the diverse landscape we have on Earth. We talk about ecosystem, and when we talk about ecosystem, we have the communities that live in this ecosystem. Then we move to another level when we talk about population and species, and here we have the gene diversity and also the wild relative species. What I would like here to emphasize in my presentation is the importance of UNESCO Biosphere Reserve. Does anyone here in the room knows about UNESCO designated sites in general? Apparently no. Anyone knows about UNESCO Biosphere Reserve and Global Geopark? So, okay, so let's see what we have here in the region. And so when we talk about UNESCO Biosphere Reserve, we have more than 300 sites distributed all over the world. So what I want to show you is what we have in terms of biome in the African continent, and especially when we talk about the Maghreb region. But let me talk about, I will just put my presentation in the context of Africa, and then I will move to the Maghreb region. So as you can see, we have many biomes in this region, and we have one of the most continent with high biodiversity and very important and marked species. We have a lot of flagship species, charismatic species, which are found in the continent. In terms of global biodiversity hotspot, you know that we have two. We have one which is on the coast of the southern Mediterranean basin, and we have also Cape Town in South Africa, and they are considered to have the high level of endemism, which means endemic species. We have here in these biodiversity hotspot in the African continent species that grows in the sites, and all they don't grow elsewhere. Sorry, it's not, yeah. So here, when I'm talking about the biodiversity hotspot, we have 5 all over the world, but we have 2 in Africa. We have here in the Mediterranean basin, and we have also in South Africa. So if I want to just have a quick round on biodiversity in Africa, so as I said before, it contains remarkable species, and it hosts most intact assemblage or community of plants and animals, in fact, and mammals. This is what is most important, is mammals. We have, even though there's a lot of protection, not only in the continent in Africa, but worldwide, we have 22% of the land, surface land is made of vital ecosystem, but we have, we have only 22% of the vital ecosystem protected worldwide. And this is why, even though there's a lot of efforts in terms of conservation of biodiversity, we still observe decline and threats to species. And they are increasing. In fact, in Africa, we have 6,419 animal and 3,148 plants which are recorded as threatened. We have 21% of all freshwater species also recorded as threatened. We have 45% of fish species, they are over harvested, and we have 58% of freshwater plant species which are also over harvested. Just a quick look on the plants in Africa. We have really very important, charismatic, and attractive plant species. In terms of bioprospection, or when we talk about bioeconomy, we can see that a lot of African plants have been domesticated, and in fact, they are found in our houses, and this is somehow a way of using the resources and the ecosystem services. Here we have, also I will go very quickly, I don't have a lot of time. Here we have the charismatic species and the mammal species, and here where we can emphasize on the importance of landscape connectivity. As you know, that mammals needs large scale area in order to reproduce and to survive. And here we have birds. So again, when I talk about landscape connectivity, I'm talking from the perspective of UNESCO and UNESCO designated sites. We're pinpointing to linking these UNESCO designated sites together among other internationally designated sites. As you can see, we have the UNESCO World Heritage Site, the natural one, in fact, and the mixed site. We have the UNESCO Man and Biosphere Reserve Program sites. We have the Ramsar sites. This is independent from UNESCO. We have the important bird area, the international plant area. We have specially protected area of Mediterranean importance, and we have the key biodiversity area. And I'm sure that some of you who works on biodiversity, you're aware of these sites. So if we look at the Ramsar Convention in terms of Ramsar site, these are the wetlands, what we're talking here. There are 50 African countries who are contracting parties to the convention. We have in the continent 259 inland wetland sites, and they cover 94,700,000 more also hectare of land area. In terms of important bird area, we have 1,259 sites, and we have 56 sites endangered. We have in Morocco for sure, we have in the Maghreb, and also in Africa. As you can see, we have many important bird area. Here in this area in the Maghreb, we don't have a lot, and maybe this needs to be mobilized, but there are other conservation approach who are taking in charge the protection of species in terms of nature reserve and protected area. Very quickly, we have, as I said, we have 3 UNESCO designated sites when we talk about landscape connectivity. We have UNESCO Biosphere Reserve, the mixed site of the World Heritage Convention, and also we have the UNESCO Global Geopark. For the UNESCO Biosphere Reserve, they are learning places for sustainable development, and there are sites for testing interdisciplinary approach to understanding and managing changes and interaction between social, ecological, and also economic factors. And we also consider the conflict prevention and biodiversity management. For the Global Geopark, the second site, we have, we consider them that these sites are single, unified geographical area where sites and landscape of international geological significance are managed with a holistic concept of protection, education, and sustainable development. So here I need, because I want to link what I want here also to bring to our audience today is that we can be considered as living gene banks. And it's very important. I'm not sure, maybe we'll have a discussion in the future. I'm not sure to which extent the project takes into account these sites, and are you working on the sequencing of species in terms of, I understood that it's now you're focusing on animals, but in the future you'll be focusing on plants. So this is why I wanted to bring these sites. Maybe we can discuss this later in the project. When we talk about biosphere reserve, we have 3 zones. We have the core area, the buffer area, and the transition zone. And each one, it has a certain role to play. The most important for us is the core area where we can consider them as living gene banks, and where we can consider them also as hubs for wild relative species. And here, wild relative species, they play an important role in food security and in the development or creation of new crop and crop variety for a human. So here we have 759 biosphere reserve, and they are distributed in 136 countries. In Africa, we have 118 biosphere reserve distributed in the whole continent. Here are some photos of UNESCO Global Geopark. I'm sorry, I wanted also to introduce our sites to you and to the students, what we have in terms, but we just have one in the Maghreb region, and it's Amgoun in Morocco. The only global geopark, UNESCO Global Geopark, we have it in Morocco, in the Arab region, I mean, and in the Maghreb region. In Africa, no, we have another Ngorongo UNESCO Global Geopark, if anyone knows about the site. So here also are different pictures and different landscapes when we consider UNESCO Global Geopark. Now let me go back to the Maghreb region. In terms of landscape connectivity, we had a regional workshop like 2 weeks ago, and we're aiming to have a regional project which will link here the countries when we talk about biosphere reserve. So we have in the Maghreb region 18 biosphere reserve, and they are different in terms of ecosystem and also in terms of the type of species, plant and animals they protect. And this is why it's important for us to have these sites linked together. So in Morocco, I'm not sure if you know what we have here in terms of biosphere reserve. We have the Argan Ray, we have the Atlas Cedar, we have also the International Biosphere Reserve of the Mediterranean, which is the first transboundary biosphere reserve also in the region here in the Maghreb and the Arab region. And we have the Southern Moroccan oasis. In Algeria, we have 8. In Tunisia, we have 4. And Tunisia was one of the first countries to designate biosphere reserve. In Libya, we have only 1. And in Mauritania, we have only 1. We're aiming, hopefully, to have other sites. So these are some of the pictures in terms of biosphere reserve in the Maghreb region. We have here in Tunis, Ashrambi, what we call it. We have Jabal Boudema. We have also the Argan Ray Biosphere Reserve in Sousse. Sousse Massa in Agadir, in this area of Morocco. We have the Atlas Cedar. We have Ishkur. It's one of really the stunning wetlands in the region. And we have also islands like Zambra and Zambretta. So here are other photos from local communities, because biosphere reserve is not only about biodiversity conservation, but we take into account also the community that live here. So if I go back to landscape connectivity, I will go quickly. Maybe I don't have a lot of time. So as I said before, when we talk about landscape connectivity, we consider the different level in terms of multidimensional approach. We consider the different level of biodiversity. We consider the different ecosystem services that are provided by the UNESCO Biosphere Reserve in terms of provisioning, supporting, regulating, and even cultural aspect. why it is important when we talk about landscape connectivity. We have a lot of challenges that we're facing at the continental level, or now I will go back to the Maghreb region. We have the climate change, we have population growth. I guess most of you know about it, and all of you, urbanization, desertification, agricultural development, and food security. The biological resource use, we have overhunting, we have trapping and logging, we have deforestation, and you have invasive species and the natural hazards which are putting at risk the ecosystem we have. Here where the biosphere reserve come to play. So I just have maybe two now slides and I will be done. So the region illustrates many critical ecological aspects, yet also holds globally important cultural tradition. So the aim of the landscape connectivity is to restitching the landscape mosaics in the Maghreb region to strengthen ecological connectivity and mobilize society for rebuilding landscape and nature. We talk here about also creating a new job opportunity. So we have connectivity not only at the ecosystem level, but also at the social and economic level. So we use biosphere reserve at the heart. It's at the heart of this large-scale initiative for ecological, cultural, and social restoration. And the aim is to protect society from the threat of ecological collapse and disaster and to rebuild ecosystem services over extensive landscape. The application is large-scale ecological restoration. We want to restore key resources for the region, including agricultural, soil, and agro ecosystem, rangeland, forest, and fishing area. I'm not sure if you heard about UNESCO initiative on soil, which was launched in Agadir in July 2024. It was launched by UNESCO, by the Director General, in partnership for sure with UNZOA and the government of Morocco. So also this initiative can be taken into account in here in this approach. So we want to strengthen the resilience and security of cities and rural community to address the impact of natural hazard. We want to strengthen resilience. It's repeated. So the main approach to implement this multidimensional methodology or concept is to use the integrated landscape approach. The integrated landscape approach, when we talk about green corridors, when we talk about stepping stone, and when we talk about ecotone, etc., in terms of ecology. I think the students or the audience, you have a biological and ecological background. So the integrated landscape approach, we want to rebuild forest, grassland, soil, and watershed supports for agricultural and fishing community. We want to strengthen the region also carbon sequestration capacities through restoration of coast, desert, and forest. We want to have entrepreneurship and jobs and income around these sites and through this landscape connectivity. And here we're talking about socio-economic aspect of connecting people together and connecting community together. We want to rebuild also social and cultural identity across landscape and community. And the most important thing here, because I'm at the university, we want to establish a robust network of regional university and institute to drive research agenda and training program to serve this multidimensional approach in terms of landscape connectivity. I'm done. I think, yes. So I'm sorry if I exceeded the time, I don't know, but there was a lot of information to be given. Thank you. I'm here for any question. At the time I had, we can talk more if you wish about the initiative or the regional project, and we would like to invite for sure university to be on board or our future. This is not happening yet, but it's now it's under progress in terms of discussion with the countries, the member state here in the Maghreb region, and we'll follow up on the implementation of this this approach in terms of connectivity and multidimensional approach. Thank you.
Thank you, Dr. Elsa. I think we can take 1 or 2 questions, and then we'll have a global discussion after the second talk. If you have any question.
Thank you very much, Dr. Elsa, for the presentations. I have just rather than question remark, because I have seen that UNESCO and AfricaBP goals are very common. I mean, it's the conservation of the landscape, above all when you are using integrative approach. I think one thing that could be a very potential point for collaboration between AfricaBP and UNESCO is the fact that sequencing of the sequence of the species, it's a great tool to enhance conservation and development of the ecosystems. And as AfricaBP, among its main objectives, to sequence the most important species in the continent. So I think there is a wide space for collaboration between the two entities. And just I would like your comment about this. Thank you.
Yeah, this is why I joined this, in fact, this conference, because I see that there might be some collaboration on working on biosphere reserve as learning spaces and also as gene banks. So this, I will discuss it back with UNESCO in terms of my director here and UNESCO in Paris, and we can have something. I have also, if we succeed to have a collaboration or a partnership, we have our office in Nairobi who will be joining, because the African project, it covers all the continent. So there will be a discussion, if you like, in the future, and we can plan for this. Yeah, thank you.
Is there any other question? Okay, it's okay. So thank you very much. And I think we can. I'm going to move to the second talk. I have the pleasure and the joy also to introduce Marwa Anzian. She's a former old student, and I'm happy to see her today at the Faculty of Science. And today, Ms. Anzian, she's a visionary leader and strategist with over a decade of experience in particularly sustainability and entrepreneurship and youth empowerment. And she has mentored over like 300 startups, and as a part of the MIT Sandbox Innovation Fund program. She's actually the founder of the Lions Club at the FSR, which is a great club, and very interested in doing a lot of programs since then. And she had a lot of awards, and then she had a lot of experience, and I encouraged all the students to get in touch with her and get also inspired. She's a success story, I think, and it's happy to have you and host you today at this event. She will be sharing with us all what she knows and how she sees the bridging research and innovation. And it's something that's so needed, because we cannot do research without innovation. This is how we keep all this research at our faculty and our institutions. So Marwa, the floor is yours.
This is for forward. This is for back.
Warm greetings, everyone. Can everyone hear me? Okay. So my name is Marwan Zian. As was mentioned by Professor Sbabu, I'm actually a former student of the Faculty of Science of Rabat. So I'm very happy to be here today, and I hope I get to inspire you because I was at your place one of these days. So I'm coming here as the director of H&M Nexus International. It's a bureau that is present in Morocco, Switzerland, Italy, France, and also US in Washington. And I'm gonna be sharing with you a bit of my journey on how can you bridge research, entrepreneurship, and innovation in order to get one winning product or idea from getting millions of dollars in order to launch your startup or your company. So from a business perspective, this is economy. Okay, this is bioeconomy. From a business perspective on how can we have a winning product is the fact that it involves renewable biological resources to create sustainable product, viable product, and processes or services. And it could be like agriculture, food sector, biotech innovation, or bioenergy and biomaterials. And as the global bioeconomy market, it's actually estimated in 2022, $4.7 trillion. So why is bioeconomy is important? Because it's at the heart of hospitals, laboratory, and it's actually one of the very, very expensive materials. So it actually helps us from a sustainable development perspective on climate change mitigation that everyone is talking about nowadays. The United Nations is working effortlessly in order to advance the Agenda 2030. And also, of course, we're talking about biodiversity here today. So it's all about biodiversity conservation and also economic growth. And we cannot talk about it without talking about the SDGs, which are the Sustainable Development Goals of the Agenda 2030. So here, how can we narrow the gap between research and innovation? The following challenges are very present in building bioeconomy startups. And let me tell you, I had students who he was at his first year of master's, and he was able to build a winning product or a service that after his graduation, 1 year after his graduation, he got un chiffre d'affaires de $1 million. $1 million. Can you imagine that? He was actually a student, not even 23 or 24. So the challenges here is the lack of pathways, okay? In his Moroccan, by the way, not talking about some foreign. He's 100% Moroccan, and nowadays he's an expert in his domain. I mean, he's under 30 for sure. So the challenges here is the lack of pathways for translating research and market-ready solutions. And you know why I'm here today? I am here to tell you that you are better than the businessman or the businesswoman who has a lot of money. You can be way better than them. And I'm gonna show you the secrets. So we have, as part of the challenges, limited access to funding, of course. And it is again why I am here to show you some of the tips and some of the secrets or funds that you're not aware of. And also complex regulatory environments and market adoption barriers. When it comes to these kind of solutions, the first step is to be in this kind of event, is to meet experts, to meet people, to talk with your professors about their expertise so they can share with you their experience, and also to really deepen your expertise in that sense. So strengthen collaboration between researchers, industry, and policymakers. And when it comes to policymakers, this is why it's very important to join associations, clubs, and so on, because it gives you we can say a vision. It can give you a way on how you can make it better, because you will be meeting with policy or decision makers in that sense. Also provide innovation hubs and incubators focused on bioeconomy startups. And here I'm going to be inviting the professors to encourage them in order to build something like that for students, or why can it be your initiative? And offer targeted funding and commercialization program. This is the kind of programs that we can have at universities. So I have to mention the R&DI. Do you guys know? Do you have any idea what is R&DI? So it's research, development, and innovation. We cannot speak or talk just about research. Nowadays, there is a famous concept that is called the R&D. We do research in order to develop something, develop a program, a product, a machine, an equipment. And they added the innovation just lately. Why? Because either when it comes to research or PhD, for example, projects, either, for example, companies or institutions, they would be funding your research projects in order to reach their goal or to reach whatever they're looking for, or you could be proposing a winning idea in order to do your research for this kind of companies. But the issue here is that a lot of, we can say research, or a lot of, let's say projects, they tend to do the same thing again and again and again. This is why they said we need to add in the innovation part, where one research project, R&DI, not just research, it doesn't have to be like the other. So guided research, it aligns with academic research and market needs, because if you are researching something that the market needs, of course, you can build up something that is impactful and you can make it a business. Fostering development, enabling innovation. Role of universities in RDI. It's actually established interdisciplinary R&DI centers to merge science, engineering, and entrepreneurship. Let's say a student from biology department is gonna collaborate with a student from bioinformatics, for example, and a mathematical student. Can you imagine the amount of idea that you would pop up? And I've seen it many times before. So provide mentorship and guidance for ternary research. So if you think of a startup, a project, at the university, you have Professor Badawi, Professor Belkhadji, Professor Sbabu. You can go to them and ask them, I need data in this. What do you think about this? Is this good? Is this bad? Is this really necessary? So at the university, you have a diverse of experts in with different backgrounds and in different expertise. And of course, we have to collaborate with industry and government for funding, especially when it comes to that comes on a later scale. And of course, promote incubators and accelerators to fast-track innovative solutions. And here, I'm gonna be talking to you about the MIT Sandbox program, where I am proudly a senior mentor with them. It's actually a program that is initiated by the Mohammed VI Polytechnic University. But the thing is, you guys are eligible. As students, you can be mentored by angel investors. Do you know what's the concept of an angel investor? An angel investor is someone who has money and he doesn't want to show his face or her face. And you could just talk to them and they would be willing to invest in your ideas. So you would be mentored by these people, by this expert, in order to launch your project. Last month, we approved many startups. One of them is actually a bioeconomy startup for a funding of 50K dirhams, just so they can establish their websites, talk to investors, other investors, go, for example, to another country or an event, just for them to launch a startup. So it's very important to note these kind of programs. It's very important. Okay, so here's when I'm going to be talking about the role of innovation. For example, we have LanzaTech and we have BallThreads. Just so I can give you an overview or an example of what you can do as students, also professors. LanzaTech takes carbon capture a step forward by transforming it into something valuable. So they use carbon emissions to create sustainable fuels. One of the many projects that I mentored just for this, the biofuels, the sustainable fuels, they would take the used kitchen oil, the oil that they're using in the kitchens, and they would try to have this bioengineering process into making it a sustainable one. Student of either the first year of their master's or a bachelor student. So it's very important to be in this kind of either events, programs, in order to get encouraged and to get inspired. Also, for example, to BallThreads, they leverage biotechnology and AI. Since we're speaking about an era, everything is digital. Everything is AI-based. In a couple of years, we're not going to be having paper-wise. All of us here are using ChatGPT, okay? You're using, and I am using AI-based tools in order to function in our daily life. So can you imagine after 2 or 3 years, what can we have? And this is where you should, in a Moroccan sense, really like seize the opportunity. So what do? They develop innovative biomaterials like Milo. So it's a sustainable use. They have a leather, but it doesn't actually affect the environment. So how? I've been talking about startups. How can you build a startup? There is many ways. And I think most of us here started with Enactus, okay? Enactus can show you how you build up a startup, or Lions Club, or whatever clubs you're gonna go to, they either gonna show you how to build a project or build a startup. So you identify a problem. And when it comes to bioeconomy, you are the one who are researching that. So if you keep researching a type of subject and you be like, maybe Morocco need these, or I'm really struggling with this machine. I wish this machine can have this option. You could actually collaborate with an engineer or an AI engineer in order to build that, because c'est un besoin, it's a need that you needed it yourself. So you identify a problem, then you do your market research. You go, you talk to people, you talk to your professors, students, and you use the university as your beta market, because we have a lot of people, they can be potential clients. Of course, collaborate, because we can never do stuff on our own. We have to collaborate with different expertise. Prototype and test. We have many programs in that sense. Mohammed V University has also many programs in that sense, when they give you a lot of utilities in order to build your prototype and test it around. And of course, pilot programs, why not at universities, in order to become a well-established company. I'm gonna give you a success story in a sense. I was mentoring a startup back in 2019, and he was still a student. He didn't even get his bachelor. And last 3 months, I went in order to register a new company under my name, and he was beside me registering also his company. So nothing is impossible. Everything is possible as long as you set your mind into it. So why startups should begin at universities? Because you have access to research materials. If you are a PhD student, if you are students working on your, for example, projet de fin d'études, you have all the materials necessarily in order to have an idea on how can you build, on what can you build. And of course, cost-effective infrastructure. You can use the facilities, also like they're high-tech, of course, under the supervision of your professors, the mentorship and expertise of different experts in that sense, and also academic credibility. Because nowadays, the startup world, startups that actually start from a university, it gives it more, it's very like, how I'm gonna say this, it gives it more importance, more credibility, because it's at a university. If we're gonna be talking about a startup that is backed up or based on a research, it's not as a startup that started just like that. There is a huge difference between the two, okay? So, of course, when I talk about startups, since it's science, since it's chemical, a product, it's international legal frameworks, you have to know this. You can take a screenshot, you can take a photo if you want, because this is very important to ensure the legal and quality standards. For example, if you wanna build a startup about a product that is gonna be, for example, eatable, you have to go to ANSA in order to get your okay in order to commercialize that product that could be eaten by people. You cannot just go and give people something like food-wise, okay? So it's very important to know about the legal complexities, the quality management, it has to do, for example, and also the risk management as well, to know about all of this, because it's very important, especially in a bioeconomy startup. And of course, you have to build networks. When I say networks, you go to this event, you meet people, you get their contacts, and you ask them, or you ask to collaborate with them. Because if you go to events where there is on-site universities, experts, private sector, public sector, you could get your startup to really like develop even better and faster. So when it comes to funding opportunities, I've gathered many funds that I've been able actually to not work with them closely, but analyze their funding programs. And it's either for startups or for research projects. So we have the Global Environment Facility. It focuses on biodiversity conservation and climate adaptation. We have the Critical Ecosystem Partnership Fund. It gives actually small grants for hotspots conservation projects. We have the UNDP Biofinance Initiative that actually support financing for the biodiversity action plans, and also World Bank Pro Blue program that targets sustainable blue economy initiative. And I have to talk about UM6P Explorer because I've been approving funds left and right for even startups that are in the stage of ideation. Once the mentors or the MIT investors, they see that this is a winning project, they actually invest in it in order to carry on. So here, when we talk about funds, some of you, especially the expert that actually worked in that sense and tried to apply for funds, it's actually quite complicated sometimes. So it's very important to know what kind of things we have to make to ensure that we have in order to apply. So it has to be aligned with the fund priorities. Some of the funds, they just see it is about biodiversity, but deep down, like in details, it either talks, for example, about climate adaptation. It doesn't talk about climate mitigation, for example. So we have to know what are these priorities in order for us to be accepted. The clear problem in impact definition. Listen to me. I've been in this for 7 years, or now I think we're going on 8 years. If you're not giving us a clear problem, a rich problem, why do I say rich? Rich in data. You say, I want to solve the worst problem. What are those problems? If you tell me 90% of women in agriculture, they are suffering from this, you would convince me, okay? So it's very important to really, really like specify the problem that you are solving. And here we can actually use the SMART method, the specific, measurable, achievable, relevant, and time-bound, because one thing about startups, it needs to be viable. And when I say viable, they need to see that it's gonna be on like time-bound. Ça veut dire, it means that it needs to carry on, because in the end, it is actually a business. And community partnership, here it's very important. Most of the United Nations funds, programs, whatever you call it, they give the priority to indigenous people, NGOs, and youth. So make sure there are many, at least, like I was saying to one of my dear professors, I receive at least 50 opportunities a day in this kind of, in these issues. Innovation and scalability, it means that you cannot provide something that it was done by everyone else. You need to be innovative in that sense. And how can we be innovative? Please, how can I say this? Like participate in innovation programs like Inactus. I've been learning how to innovate on startups thanks to Inactus. Here I'm going to talk about the IUCN. They have actually a leaders forum, change makers that you can be part of, okay? Anyone can be part of. That brings together young leaders and innovators who are designing and implementing innovative nature conservation and biodiversity action project. Okay, so actually I'm going to be talking to you about one of these startups that got the pitch. The Green Wave platform, it's actually developed by Climate Ventures. They are addressing it by consolidating data on more than 1,020 solutions providers, investors, and so on, in order to accelerate the green economy. The Diverse Seas is an open source platform for virtual reality marine science education. It's got really like the pitch from IUCN, and they are now very famous. Flint is a deep tech climate startup pioneer in new sustainable paper battery technology. Ecovan is developing sustainable sourced, newly engineered wood made from coconut husk and sugarcane bacchus. I'm going to be talking also about one of yours. She's actually a student at FSR at the Faculty of Science in Rabat. She's part of the African Youth Climate Hub program by the Mohammed VI Foundation for Environmental Protection that is chaired by Her Royal Highness Lalla Hasna. she's actually a student at FSR, and she was doing her PhD, one of the research that she was doing on algae. And she found a way on how to develop plastic from algae. And now she's getting the mentorship by the foundation. And this program is actually supported by the UN, by the UNGO. So she's getting now. It could be one of you one day, okay? So on how to apply for the biodiversity funds, make it viable. This is what I'm gonna tell you. This is the tip that you need to really get. Make it viable. We cannot talk about a business if it's gonna stop after 3 or 5 years. It needs to be a business. It needs to be scalable. We need to be at this phase and we go and we develop, we grow. And highlight partnership. If we say that this is a startup that's collaborating with NGOs, also indigenous people, it's not just a startup that's working on its own. So first, clear problem statement. Second, impact objectives. Third, budget breakdown. Fourth, sustainability plan. Many of the programs or funds, they all like highlight the importance of having your startup aligned with the Agenda 2030, with the SDGs. If I work on biodiversity, I need to make sure that I am including the SDGs that I'm working toward. If I'm working on biodiversity, for example, in a rural area, what are you doing? In a rural area, and you're working with women. We're working on with women, we're working on the rural aspects, and also the fact that you have in a startup. So it becomes rich in a sense. Example of a winning proposal, okay? A startup working on marine algae for biodegradable plastics secured funding from the GF. Why it won? The proposal addressed marine plastic pollution, a global critical issue, something that people need a solution for. If you tell me, for example, I want to build a startup in this place, and you be like, I want to build mics. I already have mics. Why would I need you? And if you tell me I need tables, I'll be like, oh, there are 2 tables, maybe I need more. I may be convinced. So if you're giving me something that it's gonna address a global issue, I would be interested. And provide a detailed impact matrix. It means that they showed, and it's very easy for you, especially research-wise, because if you research your project and you build a startup from it, it's very important. You can use that data in order to enrich your project proposal. And also, for example, like I told you, the partnership collaboration, the fact that they collaborated with local coastal communities for algae farming, which we're talking about farmers, fishers, and so on. If you need, you wish to establish your startup, or you need to secure a fund, I'm here to help you. And it's been an honor to be here and share with you some of my experience.
Thank you, Marwan. Thank you, Marwan. So we'll take 1 or 2 questions between let's start the discussion. Yes.
Thank you for the interesting presentation and very detailed information given. I just wanted to ask, Jeff is giving for individuals in terms of startups, yeah? And GNDP and GNUP, or it's in the context of a certain project developed and initiated in countries at national or local levels?
Well, I cannot know the details, but normally when it comes to startups, if you are on your own, it's not really like well highlighted.
Yeah.
You need to have a team. If you tell me that you are a biodiversity student, for example, on an expert, and you want to build a platform, and you don't have an AI engineer, and you don't have a developer with you, that's the first question I would tell you. How can you, as a biodiversity expert, you can build this kind of platform? So most of these startups normally that they get this kind of winning products, they have a robust team.
Yeah, no, this is not my question. I want to know, because I'm not aware that Jeff and UNDP are giving for individuals to have startups. It's the private sector who give the funds or give the money.
It's actually a
In
program.
terms of angel, let's say, investor or any other investor, but in terms of global environmental facilities, UNDP, we maybe launch, or even UNESCO, we work on innovation, science, technology, and innovation. But we mobilize youth, we mobilize ideas, but we don't fund them in terms of UN agency. This is new to me. I'm not saying it's not true, but I need a clarification. That's it.
Okay. So mostly normally these kind of programs, they have many partnerships. Like, I'm not sure about that as well, but all what I know is that there was a program that they got the award of funding. So it was a program by GEP. When it comes to investors, private sectors, who gave the funding, I'm not sure. I'm not internally aware of it, but all what I know is that it was part of the program, which actually happens many times. Many times, many UN agencies, they do this kind of programs where they could be partners, and we have either private sectors or investors.
Yeah,
would
that's what
actually give either shadowing programs, they would have it in their institutions or organizations, or they would actually give direct funding.
Okay. I don't think that Jeff individual global environmental facility. I will check again, but I think, yeah.
Okay.
Thank you. We have people that are following the workshop online, so we're gonna look at the chat. We had at least one question, right? Okay. Okay, so we have a question from Kalib Mokonen. How can my country, Eritrea, should involve in these institutions?
How can his country?
It's for the second talk, right? For Marwa. And my country. Okay, for the second one.
How can his country?
Yes, Eritrea should involve in these institutions. I guess all the institutions, for the funding.
Well, his country, where does he come from? When it comes to this kind of programs, we either have, for example, African programs for all African countries, or we could have a worldwide kind of program that it could address. But some of them sometimes they actually put some certain of eligible countries. Not all the countries would actually be part of this funding. Why? Because the institutions or the organizations would deem actually that it's profitable, or in a sense better impactful, if these kind of startups would function in these countries. Why? Because maybe they have this issue related to that. For example, biodiversity, it could be on the Western African countries and so on. So sometimes these kind of programs, for example, the African Youth Climate Hub, it advocates for all the African countries, for example. So you could just Google it, biodiversity funds, and it would show you all the eligibility criteria from the program statement to the country's eligibility and so on.
Okay, thank you, Marwa. I want to ask Dr. Elsa and Marwa please to join, and Professor Badawi, so we can start a discussion. But we had a question somewhere. Yes. Okay. Wait, just a second.
Okay, thank you so much. So my name is Melvin Ondiba, a PhD student at the Faculty of Sciences, Mohammed V University. So yeah, my question has already been answered. It was about the eligibility criteria. I wanted to know, is it only eligible for Moroccan students or also for foreign students who are currently in Morocco? Thank you.
So like I told you, which program, Deja? Which program? Is it the MIT Sandbox program or the AISH? Anyway, whichever kind of program that there is, they always highlight the eligibility criteria in the sense of, yes, you can, why not? Since you are a student at Mohammed V University, you have it as a card, as a student card, you could be part of the MIT Sandbox programs that's supported by UM6B Explorer. For example, we have many Mohammed V University students who are developing their startups in the program. You can just type in M6P Explorer and you could have the websites. You could either contact me. I can recommend you. It starts like that. Okay? Good luck.
So this question?
So we have a question by Huda, and it says, "Hi, Dr. Marwa. I want to ask you if your guidance and help are open even for international students from outside of Morocco." Same question. So there is an update from her. She says, that means PhD students who are working in similar projects are open to collaborate with you. Amazing.
So first, I would like to thank Dr. Elsa and Ms. Marwa for their insightful presentations. Thank you very much for being here. And we'll just have small discussions about your presentations. So I will start maybe with Elsa and go further with Marwa. So as I mentioned before in your comments, that there is a lot of commonalities between the missions of the two entities, either UNESCO and AfricaBP, which opened the door to collaborations. And my question to you, in your procedure of conserving the sites, I mean, have you used sequencing information to implement your plan of conservation before that? I mean, if you have an experience of implementing the plan of conservation using new techniques of sequencing, metabarcoding, and all this kind of things, or there is, discussions within UNESCO to use these new techniques for the conservations of sites?
Thank you, Dr. Badawi. In fact, to my knowledge, I will talk about the Maghreb region and even the Arab region, because before I was coordinating the 19 countries in the region before moving to Rabat. Not to my knowledge, we're using the sequencing to decide about the conservation approach or the management plan, and they are not one of the criteria. What we can do, we can discuss this. In fact, we're doing now an assessment. We launched an assessment with the Biosphere Reserve in the 5 countries here in the Maghreb to know what are their research in terms of research priority, and we can have further discussion, as I said, because it's interesting to decide about the management plan, 5 years, and future plans based on the sequencing in terms of plant or animal species, especially because we would like also to maybe launch these things about bioprospecting with the local community, and here where the Nagoya Protocol play a major role. And what we consider that I didn't mention during my presentation, the Biosphere Reserve are learning site to also learn how to implement the Multilateral Environmental Agreement, the Convention on Biological Diversity, UNFCCC, everything, Nagoya Protocol, Cartagena Protocol, no, it cannot be part of it, but Sustainable Development Goal, the Sendai Framework also for disaster risk reduction. We're considering them as learning spaces to upscale what we learn in terms of practices from local to national level in terms of implementation of the Multilateral Environmental Agreement. So again, going back specifically to your question, we can discuss this further, especially now that you are building a new regional project with the Biosphere Reserve in the Maghreb network. Thank you.
Thank you very much. I hope you will be here this afternoon or something, because there are many specialists that will speak about how we can use sequencing in conservation, including Professor Bazairi and Dr. Shafei and all. So just to have an idea how we can, how we can use this information. Anyway, there is a wide space for collaboration. I hope it will be fruitful. Thank you. Thank you very much. I have a question for Marwa, my ex-student. You spoke about how we can transform information, academic information, to business, and that the academician or students or the professors are more in better positions to use this information to create innovation, to create startups, taking this information. I have just one critics about this, and I would like to tell me what you think about it, because I'm convinced that academic career, it's a good way for making you, shaping your mind to think better and better, and to have a good reasoning, because you are using logics and all and reasoning and Cartesian thinking, but it's good. But academic training is a handicap too, because when you do academic, when you do research, when you are considering a lot of risks, you are considering a lot of probabilities, and you lose this ability to jump, to take risks. But doing business by itself, it needs really jumping and taking risks and going ahead and ahead. So for that, that's in my understanding, few academicians succeed in making business. Unless you have an engineer background or something, because in your training you learn something. So what you think about all that, and what you suggest to overcome this?
I actually love this question. I truly do love it, because it was what I was thinking before. And I felt like in the academic experience, it just sets you on research and you kind of like live in your laboratory. So any kind of business ventures, it would be harder for you to do so. So we have many cases in that sense. The first case that I saw is that there is this researcher. He got his PhD, he's a researcher, and he saw a need, and it was actually, he was working on crop. And he saw this winning idea, and he collaborated with someone else. If you are purely academic, this is why I talked about collaboration. If you are purely academic, you have to collaborate with someone else who would be the business face for you. So it's called actually Entomonotrice. They were one of my mentees, and now they're actually a company established not only in Morocco, actually worldwide, because there was a need that they addressed, and it was a very important. I believe, this is why I said at first, is that you could be better than a businessman with his money, because you have the expertise, you have the research, you really deepen your expertise in a certain subject. And what do they lack in that sense is that entrepreneurial mindset. So this is why it's very important to nurture it from a young age. This is why it's very important, again, that you join clubs. I'm a scientific myself. I cannot say that I am a scientific because I still didn't get my PhD. Hopefully I will. But it helped me have this scientific background, but also be able to venture in business, because nowadays I actually have 3 businesses so far. I'm dying in order to establish them all. But I'm actually was a student at FSR. So it's very important to nurture that entrepreneurial mindset, because it's very important. And what do most of PhD students? Either they have it in them, it's like the DNA, even though they are PhD and it's so much hard work, they don't have time for themselves, but you can still find them working on a startup. Or some of them actually focuses on their PhD until they're done. They have all the data, and then they venture. But if they don't have that kind of mindset, they collaborate with someone else. And one of the things that I love about this, maybe you would not like it, but I do, is that they clash. The business mindset partner with the academic, purely academic partner, they would clash in discussions because they don't have the same kind of vision. And this is where most winning ideas actually, I say, get born in a sense, because if you challenge me and I challenge you back, it means we're discussing, we're debating on how we can make it better in a sense. Well, it's still a handicap, not gonna lie, it is still a handicap, but if you either nurture it, that entrepreneurial mindset, or you find yourself a good partner with a good communication style, because most of the academic people is that they're so not used on, like, they're so practical, right to the point. I need to do this and that and that in that scientific kind of process, and they don't have time to communicate in a sense. So that's actually my intake. I may be wrong, but if you find yourself a good partner, it could actually work, and it worked many times. I've seen it. Why not? Because you're better than a businessman with his money, because you have the expertise, you have the experience, you know what's the winning product, because you yourself, your first client.
Thank you very much for this convincing answer. Thank you. You would like to say something?
Thank you. I think in the same way, I was looking at way, like a practical way how to address, like to have a bridging. I was okay now. Okay, the way to effectively, bridge the gap between the fundamental research and the startups, market-driven innovation with all the protection of intellectual property. So how can you do to have, this mindset of transforming this fundamental research in, this, innovation and market-driven, as I said, innovation?
Okay, so it's very, I don't know, maybe for me it looks so easy because I've seen it, especially when it comes to young people. For example, we have senior business mentor. They would actually call for an expert, and they would give them a certain, let's say, either a consultancy kind of opportunities, but they would never take them as a partner. That's the thing. And this is where you should actually narrow the gap, because you could be a partner in that company. You could have a percentage. You could be a businessman or woman yourself. So this is where, for example, when I saw, this is why I talk about Enactus, because Enactus, I don't know if you know the concept of a club, is that you join it and they show you how to build a startup. And they give you this kind of challenges that you need to work on building your startups. And many of my colleagues and friends, they were able to launch their first startup, even if it failed, let's say it failed. They learned. There was they're no more afraid of establishing a business, even if it fails, because that's the first lesson we learn, is that you do your business. In order not to have a failing business, you need to do good market research. And who else can be better in research than researchers themselves? Because they know, they are the one researching. So I've seen this, let's say, a switch. First, there was kind of services, communication, soft skills, hard skills. But lately, I've seen a lot of doctors, medical doctors. Like there is a medical doctor who was working in a hospital, and she was like, "I'm struggling with the kitchen, quality management wise. When, for example, a nurse or someone else would bring the food, it's not good quality, especially when it comes to, for example, viruses and so on. So how can we make it digital?" And she's working on making a digital kitchen for the hospital. So it's just either you nurture it from a young age. This is why I told you later on, like, please, professors, encourage students in that sense. They would bring you that youthful spirit in a sense, but also like having a bioeconomy startups in a scientific university could be really helpful. And in that sense, you either nurture it or you partner up with someone else, or you go to events. You have to be trained in a sense. It's very important to be trained to meet up with this kind of people, like people who were researchers and they become I can say businessmen or startup holders. I actually do remember, one of the students, Fatih Al-Hloumi, I guess, she was also one of your former students, and she was part of this startup as well at UM6P. So why not? It could start from now. Like with your expertise, you would know better because you are researching. You are the one who's at a deeper level at the issue, at the subject. And I think tech-wise, and I have to share this, you were very tough on us on one of the classes in bioinformatics. Like she was showing us on how to do it with a platform. It was very hard for us. And that's where it clicked that we need to get trained in that sense. So it was hard at first, but then later on it became easier. So that's what it is. It's sometimes beginnings can be hard, can be tough, but later on, when you have that kind of mindset, nothing can make you scared. Like I told you, I have 3 businesses and I just had a meeting with an investor. He was talking to me about one of his projects and I was like, I do have one project of mine. Do you want to invest in mine? So you would no more have that kind of fear. And I don't have that much experience, to be honest. I'm not a senior. I've been working while being a student, but still, like there are better people here, way better than me. So if I can do it, why can't you?
Thank you very much. So I want again to thank warmly our doctors, Marwa and Elsa. And if there is any question, please, before closing the session. Yeah, please, yeah.
Good morning. I'm Elise Nzigira Gutakaza Nathalie, a PhD student. I want just to ask if there is any training or that you did to start working in bioeconomy, or you just do biology and then after you convert in bioeconomy. Thank you.
Okay, so I will answer your questions by telling you this story. So you're a student here, right? Okay. So one of the investors I was working with, he was like, why didn't you study business? You could become way better in that sense. I would never regret being a scientific or a student who studied biology, because scientific process or scientific research, I can say, it gives you this kind of mindset that helps a lot in your later on in your life. When you go to micro, macro, macro, micro, l'ecosystem, everything, like mathematically speaking, biologically speaking, it helps you become, you could have a strong, rigid kind of mindset in order to tackle really like daily issues. So in that sense, when it comes to training, I was a student here at the Faculty of Science, but I was participating in many. I didn't have time for myself, to be honest. It was Saturday, Sunday, from 7 a.m. to 10 p.m. to 11 p.m. I would go to my school. I was also the delegate. I was in charge of responsibility with my professors, but I would go to trainings in NGOs, Enactus, Lions Club, Word Merit, GCE, many of them. I was once called Marwa with her balloons, like her NGOs. Whenever we go, she's there. But they were offering free training. Why wouldn't I go? So I was trained. I was able to meet a lot of people. I was able to expand my network in that sense. That's what was actually allowing me to work at such a young age in really like strategic kind of positions at the Mohammed VI Polytechnic University or the Mohammed VI Foundation for Environmental Protection. So that's my answer for you, is that please use the clubs that are here. And now you actually have a dean who is very open. You have professors who were very open. At my age, I think Mr. Badawi and I were talking like he was actually a mentor of mine. So if you find yourself a professor who would become a mentor, that would be actually good, because we were having a lot of discussion. And at that time, the dean was not really open to opening up clubs. But later on, Professor Belqadi helped us and shadowed us in order to create our club. So it's very important for you to be very active. And nowadays, please, أفاكم, I'm going to say this in the Moroccan way. Hard skills are not enough anymore. People do have 2 masters, 3 masters, 2 doctorate, 2 PhD, and it's not enough. So you have to back it up with soft skills. If you're good at mathematics and biology and you don't know how to communicate or you don't know how to manage a team, it's not going to help you. So soft skills are very, very important. And how can you acquire that? By becoming active. Because this is your youthful days and they're going to stop at one day. And I don't want you to stop one day and regret and say, I should have been more active in that sense. But also be good with your studies, of course. Okay.
Thank you. Thank you very much, Mawa. You would like to close the discussion? Yeah. Yeah.
Hello, everyone. My name is Hajar Ahmouin. I'm a student and Master of Genomics and Bioinformatics. Actually, I have 2 questions. The first is, based on your experience, what are the advice you can give us to choose our partner? Because sometimes if you're doing a business or even a small project or something, you struggle with finding a good partner. If the person is good in the professional way, maybe in the personal part is not good enough. So how can we manage it? And also, my second question is, the project, the business, it's forcefully should be related to what we study, or maybe we can do something in that we have other interests out of school, out of university. And thank you.
Okay, so when it comes to advices, I didn't want to monopolize the discussion, but I would more than be open to discuss it with you later on, or you can contact me whenever you want. Okay, so when it comes to having a partner, it's like marriage. Okay, it's like marriage. It's money, it's business, it's percentage. You cannot be with a partner that you don't trust. You cannot be with a partner that you don't have the same vision with. If you have different backgrounds, it's more than okay, Blex. It's way better to have different background, different expertise in order for you to have a melting pot of expertise. You with your scientific background, him or her with her communication background. Because one of the things that make startup fail, especially in funding programs, is that when you have a good idea, but you don't know how to pitch it. You don't know how to communicate it, or you give a bad presentation, or you don't enrich it with data. So you have a good project, but you don't know how to talk about it. So it's very important to have partners. In that sense, you need to build up either a good, I'm not saying a business partner. You just have to have the same vision. You want to go to the same goal. And of course, you're going to fight. Of course, you're not going to agree on stuff together. And if you agree, that's not good. If you agree on most of the things, it doesn't give much space for growth. Because growth comes from disagreements, come from the fact that I see it in that way and you see it that way, but the goal is one. Let's say, for example, I will come to you. Mr. Badawi, Professor Badawi is my partner. He would go this way and I would go this way, but the end goal is to go to you. So he's going to use his way and I'm going to use mine, but the end, it's one vision. So that's what's most important about partners. And of course, you don't have to align on many things. One thing that I could tell you is that don't make it personal. You can't build a business with your friend because at some point you're going to fight. And the personal, professional kind of relationship may overlap and it may actually not be good. So what I do, for example, when I used to have startups with my friends, I would tell them, once we are in a meeting, I wouldn't care about you or what I care about the project that we have. And once we're done with the meeting and we go like from the door, let's hug, let's go grab a coffee, we're friends again. But in the meeting, we're not friends, we're business partners. What was the second question? Like advices, I would more than be happy to give it to you, depending on the personal situations that you have. Okay, so I have a lot and let's discuss it later on. Okay.
Thank you very much.
Well, it was such an interesting discussion, and thank you to the speakers for their, sharing all their knowledge, and I think we can share their emails so with the audience so they can contact you for further information, and we need to, right? I have just four words that I say I can as a final words from the talks. The first one is capacity building. So keep doing all the workshops and trainings and invest in yourselves. The second one, self-confidence. As you see, Marwa, she's an example. The 3 points is think out of the box. So this is the way to see other something else rather than our bench in our labs and do innovation. And the fourth one is collaboration. So it's very important, collaborate. And thank you for your assistance. And I think we're gonna close all the first session, and we're gonna jump, no? Nice. Okay, so we are going to have the lunch break, and we are going to meet again in the same place in 1 hour. Like 2 p.m. 25 or something, or 30. Huh? Thank you. Okay. How quickly?
No estás deprimido, estás distraído. Distraído de la vida que te puebla. Tienes corazón, cerebro, alma y espíritu. Distraído de la vida que te rodea. Delfines, bosques, mares, montañas, ríos. No encuentras la felicidad y es tan fácil. Solo debes escuchar a tu corazón antes que intervenga tu cabeza. Está condicionada por la memoria. Complica todo con cosas viejas. Con orden del pasado. Con prejuicios que enferman, que encadenan. La cabeza que divide, es decir, empobrece. La cabeza que no acepta que la vida es como es, no como debería ser. Solo
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions. push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life. Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products, and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
Okay. Bonjour tout le monde. Je vais parler en anglais. It's okay. So we're going to start. Good afternoon, everyone, and welcome back after lunch. I hope you are feeling refreshed and ready for what promises to be a highlight, insightful session. Today, we delve into an exciting and critical topics, that is navigating biodiversity and sustainability insights from marine, agriculture, and economic perspectives. As North Africa seeks to advance in its bioeconomy, leveraging biodiversity genomics is a key strategy for sustainable growth, especially in sectors like agriculture and marine conservation. This session will explore how the intersection of these fields, marine ecosystem, agricultural practices, and economic policies can drive innovation in sustainable resources management and find solutions that not our ecosystems, but also foster long-term inclusive growth for the region. We are fortunate to have an excellent lineup of experts today who will share their insights on how genomics tools and innovative policies can enhance biodiversity conservation, support sustainable agriculture, and strengthen the economy foundation of our bioeconomy. So without any further informations, let's begin with our first speaker, who will share his experience, and he will talk about the marine and coastal biodiversity in the Moroccan Mediterranean, achievements, challenges, and perspectives. Professor Hussein Bazairi, that I will present now. He is a senior professor at University Mohammed V and a senior researcher associate at the University of Gibraltar. He is also an international expert on marine biodiversity, and he collaborates with many organizations. His research spans benthic macrofauna, parasite ecology, trophic interactions, marine mammaliophyte, and ecological restoration. Since 2002, he has focused on marine protection areas, including their ecological characterization, conservation, and management. He has coordinated numerous national and international projects and supervised many academic research. So we invite Professor Bazairi on the floor. Thank you. I'm gonna just to tell you that all the questions will be at the end of the session. Thank you.
So good afternoon. So today, the theme of this workshop, as you see, is advancing North African bioeconomy through biodiversity genomics. And my thought was that we will talk mainly about green economy, which is defined as low in carbon, socially inclusive, and resource efficient. It means that this kind of economy that can provide sustainable jobs, resilient lives, and healthier lives. However, in this edition of this workshop, in the last edition, I noticed that ocean it's a sort of neglected topic in this biogenome project. That's my point of view. Maybe it's not priority now. Thank you. And as you know, the ocean, the global ocean, is vital for the global economy. We rely on many services, ecological services, economic services that provide these ecosystems. And we can resume this, that we cannot be green without blue. Blue, or what we call ocean economy, is the sum of economic activities. You know here in this picture, a kind of activities that can be done in to achieve this blue economy. It means that economy has to be sustainable in where the humans are in the center of the development, but we have to, this kind of economy had to be sustainable in terms of human well-being, social equity, and so on. So my talk today, I will invite you to dive with me in the Mediterranean as a showcase, and particularly the Moroccan Mediterranean. And this is the opportunity to talk about links between biodiversity, mainly coastal and marine biodiversity, how it's linked to bioeconomy, and what are the opportunities in this field of science. So the Mediterranean, sorry, the Mediterranean, it's a hotspot for biodiversity. It occupies, only less than 1% of the world ocean volume, but it harbors, it's home to 4 to 18% of the global marine species, from which 25 are endemic to this basin, to the Mediterranean. So they exist only in the Mediterranean basin. However, this is a hotspot for biodiversity, but it's an ecosystem under pressure, man-made pressure and natural pressures, and it's considered today as also a hotspot for climate change, with many heat waves that cause many mortalities, mass mortalities in the marine ecosystems. So among this pressure, you have the maritime traffic and the touristic activities that constitute one of the major pressures on marine and coastal ecosystem, bromine exploitation of hydrocarbons at sea, exploited resource. Currently, most of the fish stocks are overfished, like elsewhere. And there's many pollution and drastic impact, and one major pressure, it's related to non-native species. It means exotic species, among which there's many invasive that cause many negative impacts on the marine and coastal ecosystems. In this slide, we see that the Mediterranean Sea contribute to the global blue economy. And here you have some numbers. The economic value of ocean-related activity in terms of gross marine product, it consists some 450 billion annually. It's like 20% of the global marine product, and from which 92% are related to marine and coastal tourism, and only 2% are fisheries and aquaculture. So you see that the Mediterranean is related to the blue economy, and biodiversity. It's a keystone in this blue economy because it's the source of many ecosystem services. And one of the major tools to protect this biodiversity and marine protected areas. These are nature-based, I'm sorry for this, I'm not, nature-based solutions, but they have to be well designed, well managed, and well enforced because they can generate incomes two to three times more than their management. So marine protected areas are tools, area-based management tools, because they provide key habitat for fish, though they enhance the activities of fisheries. They are also the generate an increase in the number of visitors inside the marine protected areas. And currently, there's a big discussion, a relevant discussion on what is a protected area. And for many people, they think that protected area is something which is close to the human activities. It's not the case. The humans have to be in the center of any activities of this kind of conservation. And they also considered as tool enabling marine ecosystem to act to enhance their resilience to marine heats and globally to climate change, including the warming that we observe all over the world. One of the there's many efforts to protect the Mediterranean, and that's the framework, the legislative framework is the Barcelona Convention system, which is coordinated by UNEP. And there is a Mediterranean Action Plan, which with 6 regional activity centers, and one, here you have the six activity center with the MedPol program, and the SPARAC, which is the biodiversity center of the Barcelona Convention, is dedicated to the specially protected areas and biological diversity. And there is a protocol in the Mediterranean who is in charge of assisting countries to protect their biodiversity. So here is a brief description of what the activities that are in charge of the Marine Biodiversity Center of the Barcelona Convention. They help countries to do inventories, to develop research, to conserve, to create and enforce MPAs, and so on. This is the picture we have now in terms of marine protected areas in the Mediterranean as tools for conservation of the marine and coastal biodiversity. And you see there's a clear shortage between the north and the southern Mediterranean. Most of the marine protected areas are in the European waters. So there's many initiatives from the Barcelona Convention to enhance the marine protected area in the southern Mediterranean, and I will talk as a case study in Morocco on what the achievements had realized in this part of the Mediterranean. Another tool for Mediterranean cooperation and coordination is the SPAMIs. It means Special Protected Areas of Mediterranean Interests, and that's kind of label that is the Barcelona Convention gives to some sites because there's many criteria, and one site, if it's declared SPAMI, it means that it has an regional importance beside its local importance as marine protected areas. And there is till now 39 SPAMIs along 11 countries. This is in this slide, what are the targets, ASHI targets? You know that at the level of the world, there's targets to achieve number of percentage of conservation, which is the target ASHI by 2020, which was those 10% of the coastal and marine area. And we reached it in the Mediterranean 0.3%. And in the Mediterranean, targets by 2030 are 30%. So, you know, there's a big challenge in terms of conserving our coastal and marine ecosystems. So now, what is the situation in Morocco? As you see, Morocco, just after the Rio summit, has decided to do a master study to recognize ecosystems or sites that could be declared as protected areas. And there was many types of protected areas, marine, continental, and so on. And this is the pictures, what we have in the Mediterranean. These sites, numbered from 1 to 10, are the 10 sites that were recognized as sites of biological and ecological interest. At that time, in between 93 and 95, there was now jurisdiction to declare them as protected areas, because there was only visual declaration as who allowed to declare them as national parks, and there's no legal jurisdiction to declare other type of protected areas. And by 210, Morocco has adopted a new lay on marine protected areas, in which he recognized many types of kind of conservation. It's a site, can be reserved, it can a national park, and so on. And there's a vision that he wanted to create a national network of protected area that were managed in an integrated and sustainable way for the conservation of biodiversity and sustainable development. And in this guide, the center that I called the SPARAC, which is in charge of assisting people, had done many activities in the Moroccan Mediterranean in order to assist Morocco to identify this network of protected areas. So the first activity was in 2012 in the framework of a project called Med-MPNet, which was executed by SPARAC. And in this project, the idea was first to prioritize, to do a prioritization of the sites that were already identified by the Morocco in that was a question asked by the Moroccan authorities. So the idea was to draw up a list of property sites identified as sites for conservation that could be declared as marine protected areas. And based on what the knowledge, the existing knowledge, and based on criteria, SPAMI criteria, the Barcelona Convention, on the Biodiversity Convention criteria, there was an effort to prioritize, to do a priority of the sites, because in the framework of this project, the idea was to help to support countries to declare new protected areas. So we worked, I had the privilege to coordinate since 12 without all the projects that were the project executed by SPARAC in Morocco. And this is the result showed that the first site, it's Cap de Trois Fourches, and then the second site was Jebel Moussa, and the second site were Jebha, are the three sites that deserve to be declared as protected areas. But in the framework of the same project, there was a possibility to do many studies, field work with many teams, many topics, including many experts from our university in Rabat, and the University of Sevilla from Spain, and many students, PhD students that were trained to work and in this work that evolves a combined approach, benthic community rock substrate, fish census, the study of Patella ferruginea with the most threatened invertebrate in Mediterranean, underwater caves, and so on. And the results, and we do and afterwards a mapping of benthic habitat. And here one of the ecological value of the site is to see how many species and habitats of interest in the Mediterranean. There's some lists, the annexes of the Barcelona Convention. In this cap of this forecast, we found that there's many species that are listed in the Annex 2 of the Barcelona Convention as species of conservation interest in the Mediterranean, and also some habitats that were key habitats for the marine conservation in the Mediterranean. And definitely the Cap Trois Fourches has all the scientific qualities to be set up as a marine protected areas, because this kind of formation there was new, because in the in the years before it was just little information, there was many gaps, and this could to enhance our knowledge on the marine and coastal biodiversity in this system. Here you have some photo, the Merle, you have some submarine caves, and so on. The second exercise in the framework of the project Mid-Key Habitats that I have the privilege to coordinate also in Morocco was to do the same thing in Jebel Moussa, which was the second priority site for the Moroccan Mediterranean. And we do the same thing with the University of Barcelona, University of Sevilla, and many students. And we found that we had this site is home to 12 species that were listed in the Annex 2 and 3 of the Barcelona Convention, and many 10 habitats that of conservation interest in the Mediterranean, what we call a coralligenous habitats. And here we have a red color that we found at a depth of 14 meters. It was exceptional in the area. And here also, we demonstrated that the marine part of Jebel Moussa has all the specific qualities to be set up as a marine protected area. So as you notice that SPARAC, which is the center, the biodiversity center of the Barcelona Convention, supported Morocco in this roadmap to identify how it's called, to identify network of marine protected areas on its Mediterranean coast. And this summarizes a little bit all the projects that were executed by RATSPA in the Mediterranean. And you see that it's in many sites in Tres Forcas, in Al Hoceima Park National, which is the unique official declared MPA in Morocco, in Cirque du Jebha, and the Jebel Moussa. So the picture we have now in Morocco in terms of marine protected areas is this. Yes, we have 20 sites of ecological and biological interest, one and unique marine protected area officially declared in the framework of the Barcelona Convention. We have MPA for fisheries management, which is not the same thing. And we have Tres Forcas, Cap de Trois Fourches, and Jebel Moussa that are candidate, are on the list as sites to be declared soon by Morocco as protected areas. And therefore, one need that was identified that we need to strengthen the role of marine protected areas in conserving marine and coastal biodiversity, because this network has to be well designed, well connected, and well managed with well enforced marine protected areas. This Just to show you one study that we have done regarding our knowledge on marine biodiversity in Morocco. And this is indicator. If you are interested, we can share with you all the data that allow to calculate, or to estimate, to appreciate this indicator state of non-dwelling. And you see that we have our knowledge is insufficient to have biodiversity, to assess the biodiversity and natural heritage of our marine and coastal areas in the Mediterranean. So there's clearly a need to improve our knowledge on marine and coastal biodiversity in Moroccan Mediterranean. But the efforts that have done since 2012 has enhanced our knowledge. And we recorded more than 100 species of conservation interest in the Mediterranean and 27 habitats, but our knowledge is just a list. We don't know how many there are. There's no mapping, and this kind of things are important if we need to conserve efficiently our ecosystems. So now the most important part, Morocco, as many countries in the Mediterranean, has launched this vision to recognize many or to identify a network of marine protected areas, because we are convinced that this is a worldwide recognized tool to prevent biodiversity and to conserve their functional and their socioeconomic services and their involvement in the blue economy. So what are the opportunities for genomics? And that was the idea why I proposed this presentation, because it's an invitation to my colleagues, to the African BP project, to include in their strategies the marine and the coastal ecosystem. There's a lot of things to do. And here just I enumerate what we can do with genomics and in the Mediterranean and also in Morocco, mainly in Morocco. So it could help in area-based conservation, MPA, and I will give an example. It could help in biodiversity, in doing inventories of species and so on. It could help in understanding the history of bioinvasions in our country. It could help in doing some monitoring. And sometimes it's very difficult because many species are cryptic, and it's difficult to do direct monitoring, and genomics or omics can help, molecular methods can help in such monitoring. I will give you an example. It could help in fisheries management. I will give you also an example, but one of my PhD students was published in this topic, will do a presentation, will talk more in details about this topic. And it could also help in the ecology restoration. It's not all the topics, it's just some of the examples where omics can help in conserving marine and coastal biodiversity. So let's start with area-based conservation. There's a paper published in 2022 showing that there's a clear interest in omics when talking about marine protected areas. So there's two aspects that omics can help in this, what we call area-based conservation. It can help in initial MPA design, because one of the most important in identifying this network is connectivity between the MPAs that constitute this. And omics are tools that can measure connectivity and collect balance of species resources. So it can help in designing MPAs that are connected and representative of our diversity. And this is essential need for what Morocco wants to do and to identify the sites that can constitute his network of species. Another thing is this omics can help also in MBI conservation objective monitoring in programs. Here I give some examples regarding the identification of fishes research on species beside and outside. I don't know how it's done, but I see that omics, that it's something is published and the scientists can give answers to this kind of questions. Another interest is fish diversity. It's the assessment of biological diversity. And here I give an example of study that was undertaken in the Marchica Lagoon on the Mediterranean coast, when we have in the framework of PhD done a scientific survey based on more than 20 stations monthly during 1 year. And overall, we recorded 86 species. However, we tried 2 years ago to do environmental DNA, and with one shot, five stations, simple ones, we managed to record more than 112 species. So this is omics are promising tool because what we have done in 1 year, we managed to do it with just one shot. And one thing, it's more important that this kind of tools allowed us to identify some cryptic species, because this is a site that we know, and all the habitats are, we know that some species, there are habitats that are suitable for some fish species, some go bit for them, but we didn't manage to catch them by our sampling geo. So here with eDNA, we found the cryptic species that we suspect their presence, and we cannot sample, but with DNA we managed to do. And this is a tool can be used as how it's called alarm for mainly for invasive and non-indigenous species. This is also something that we are doing in our laboratory in here regarding the bioinvasion ecology, and this is the photo of the Atlantic blue crab that became invasive and well established in coastal and marine ecosystems along the Mediterranean and the Atlantic coast. And here there's a PhD student, which is she's now in Belgium. And her top subject, she's working on parasites of the invasive, because you know the invasion, it's a risk for associated parasites that can provoke many mortalities in native biodiversity. So the objective of genomic here, we use it as a tool to understand the pathway of introduction, what are the origin of what are the origin of the introduction of this species to Moroccan waters, and to check also for ecological genetic signature of the invasion of this crab in Morocco. For the fisheries management, this case study of the Atlantic sharp mackerel, and my PhD student will present you a presentation, will do a presentation tomorrow, I think. The fisheries management is the basic thing, and this essential and key thing is that we have to identify the stocks that we are talking about in here. So the stock identification is a central theme in fisheries science, which involves recognizing self-sustainability. So what my our PhD student is doing is recognizing the stocks, how many stocks there are of the species, because it's paramount. It's very important in managing this kind of fisheries. And to finish, this is the monk cell, which is a protected species, which is endangered species in the Mediterranean. And there was a population here along the Mediterranean coast in Al Husayma in the Cap des Forecast, Cap des Trois Fourches, and the study that we have undertaken in 22 and 202 and 204 allows us to identify many caves that are can work, they are suitable habitat for the monk seal. But the latest individual that was observed was in summer 204, I think. And there's no species. Now the question, why monitoring the species? Because the remaining populations of the species in the Mediterranean are in Turkey and Greece. But this last years, we observed that some ambassadors, what we call ambassadors, some individuals or these species were observed in Tunisia, for example, in South. The idea, it's maybe there's some individuals can visit this suitable habitat. So the idea, there's now a project on this aspect, on this topic, and to try to monitor this cave. So one method is to install their trap cameras, but another method is omics. It's to do from time to time water samples to analyze DNA to see if we can find some signature of the presence of this kind of species, because one individual, it's time consuming, a lot of money to monitor if these caves in the Mediterranean are visited by individuals of this species. So that's the picture we have in Morocco. I think that I reached the end. Thank you for your attention, and
Thank you, Professor, for this speech, very interesting one. And I don't know if we take questions now, or maybe I will invite the next speaker. I will ask Professor Badawi. Will we take the question now or till the... Yes, okay. So please, I'm going to invite now our expert, Professor Rashid Harbouz, and he will be talking about economic evaluation of biodiversity and ecosystem services. I'm going to present him. So Rashid Harbouz, that we have the chance to have, fortunate to have you, holds a PhD in economic sciences from the University of Montpellier and in economic and social sciences applied to agriculture from l'Institut agronomique vétérinaire Hassan II. With over 15 years of experience, he specialized in the economic and financial evaluation of agriculture, forestry, and agroforestry projects, programs, and policy. Dr. Harbouz has a strong understanding of sustainable management strategy and has led public and private projects focusing on strategy, planning, implementation, and monitoring. He is experienced in analyzing public financing in agriculture and rural development and in the evaluation of market and non-market goods and services. Additionally, he has developed management and development plans for protected area also, but not in the ocean. Harbouz has significant expertise in European Union programs and conducted studies on agriculture advisory services in the country. So please, we are going to welcome Dr. Harbouz. Thank you.
Donc, merci beaucoup. Donc, je suis très ravi d'être là parmi vous aujourd'hui. Je remercie le professeur Badawi de m'avoir associé à cet événement. Donc, aujourd'hui, on va parler un peu de l'évaluation économique des services écosystémiques et de la biodiversité. L'autre. OK. Donc, le plan de la présentation, donc, je vais commencer par des indicateurs qui sont tous en rouge pour le déclin de la nature qui se poursuit, l'importance de la biodiversité et l'évaluation écosystémique des services écosystémiques de la biodiversité, la valeur économique totale, la définition de cette valeur économique totale et les approches d'évaluation économique. Et je terminerai par une conclusion. Donc, je commencerai par les 9 limites planétaires. Donc, les 9 limites planétaires, donc, c'est un cadre proposé par le Centre de résilience de Stockholm en 2009. Donc, c'est un cadre proposé par des scientifiques pour déterminer les limites acceptables du système Terre, au-delà desquelles donc, le système Terre est vulnérable et moins résilient. Donc c'est 9 limites. Donc, en 2009, en 2021, donc, c'était donc, le système Terre, donc nous avions dépassé 5 limites et en 2022, donc, à ces 5 limites, donc, l'eau douce a été dépassée, c'est-à-dire au-delà de ces limites-là, donc le système ne se régénère pas. Donc, ce qui est vraiment très, très grave. Pour les indicateurs qui sont rouges, donc pratiquement tous les indicateurs sont rouges. Donc, l'indice planète vivante mondial, donc depuis que les statistiques ou le suivi des espèces, donc ça a commencé en les années 70, 1970. Donc, il y a moins de 73% des espèces qui ont disparu. Donc, c'est moins 73% des espèces qui sont suivies par la communauté scientifique. Indice liste rouge aussi pour à peu près pour les oiseaux, pour les amphibiens, etc. Donc, c'est en déclin total. L'indice d'intégrité de la biodiversité aussi, c'est en chute libre. Et aussi le taux d'extinction qui augmente d'année en année. Donc, à ces indicateurs, on peut ajouter d'autres indicateurs, le jour de dépassement, par exemple. Donc, le jour de dépassement, c'est un indicateur qui définit l'exploitation des ressources renouvelables au niveau de la Terre. Donc, au-delà de ce jour-là, donc, on exploite des ressources non renouvelables et on ne veut pas les régénérer. Donc, cet indicateur des dépassements de jour de dépassement, donc, ça a commencé dans les années 70. Donc, ça a commencé au mois de février, c'est-à-dire on avait 1 année et 2 mois à exploiter les ressources renouvelables. Et en 2018, on est arrivé au mois d'août. Donc, c'est-à-dire à partir du mois d'août, donc la planète vit sur crédit où il exploite des ressources non renouvelables. Donc, l'importance de la biodiversité. Donc, la biodiversité, donc, il sert au maintien de l'équilibre écologique, résilience face au changement climatique, environnementaux, fourniture des ressources naturelles, soutien à l'agriculture et à la sécurité alimentaire et l'inspiration pour l'innovation et la recherche. Donc, les services de production de la biodiversité, donc, c'est tout ce qui est production alimentaire, matières premières, médicaments, production d'oxygène et régulation climatique. Donc, les services de régulation, donc, c'est tout ce qui est régulation climatique, contrôle des pollutions, contrôle des événements extrêmes, mise en avant des services de régulation et aussi le contrôle de processus biologiques. À titre indicatif, donc, le système forestier, donc, pour tout ce qui est séquestration de carbone, pour la régulation climatique. Donc, la séquestration de carbone, donc, il y a le système forestier et le système sol. Donc, le système forestier séquestre plus que le système sol. Mais en 2022, donc, ces deux systèmes ont séquestré à peu près 9,5 milliards de tonnes. Et seulement en 2023, c'est 4,1. Donc, c'est à peu près la moitié que ces deux systèmes n'ont pas réussi à séquestrer, ce qui engendre du changement de réchauffement climatique, etc. Donc, c'est dû à tout ce qui est en 2023 aux incendies immenses qui ont touché la planète et aussi à la sécheresse. Et on a aussi les services culturels, donc c'est tout ce qui est valeur esthétique, bien services écosystémiques de la biodiversité, patrimoine culturel, inspiration artistique et activités récréatives pour tout ce qui est pour les parcs ou les ressources en général. Donc, comment on définit cette valeur économique? C'est-à-dire, la valeur économique, c'est de donner une valeur à des biens qui ne sont pas marchands. Donc, c'est-à-dire qu'ils n'ont pas de valeur, mais on essaie de leur donner une valeur pour démontrer un peu leur importance et plaidoyer au niveau des politiques pour leur préservation. Donc, la valeur économique repose sur l'utilité sociale, bien-être. C'est pas sur le prix. Il est subjectif. Donc, il mesure la variation du bien-être résultant des changements dans la qualité ou la disponibilité de ces ressources ou de ces biens-là. Donc, différence entre valeur et prix. Donc, la valeur repose sur l'utilité que procure ce bien et ses services. Donc, exemple, donc l'eau est très utile, mais son prix financier. Donc, je parle du prix financier. Donc, son prix financier n'est pas nécessairement élevé, alors que son prix économique ou sa valeur économique, elle est très élevée. Donc, il dépend, cette valeur économique est subjective et il dépend de l'analyse utilitariste, c'est-à-dire de l'utilité de ce bien pour toute la collectivité. Donc, le cadre général qu'on utilise pour la détermination de la valeur économique des biens et services environnementaux ou pour la biodiversité, ce qu'on appelle la valeur économique totale. C'est-à-dire que chaque bien ou service, il a une valeur d'usage et une valeur de non-usage. Donc, la valeur d'usage, c'est tout ce qui est direct ou indirect ou valeur d'option. Donc, tout ce qui est direct, c'est la nourriture, le bois, le biomasse, etc. Donc, ça, c'est une valeur économique totale pour la forêt. Donc, tout ce qui est valeur d'usage indirect, c'est les avantages fonctionnels, c'est la fonction de protection, c'est la fonction hydrogéologique ou hydraulique et la fonction écologique. Et tout ce qui est valeur d'option, c'est l'usage futur qu'on délègue aux générations futures, c'est-à-dire la conservation de la durabilité, la protection de la biodiversité, le paysage. Et la valeur de non-usage, c'est la valeur d'héritage et la valeur d'existence. Donc, les approches d'évaluation économique pour ces biens et services, donc, ils sont dans l'ordre de 3. Donc, c'est des méthodes basées sur les coûts observables, c'est-à-dire directement ou indirectement sur l'effet de la productivité. C'est des méthodes basées sur les préférences révélées par les comportements observés sur les marchés. Et aussi, c'est des méthodes basées sur des préférences déclarées lors d'enquêtes pour les usagers de ces biens et services. Donc, le choix d'une méthode dépend de la nature de l'actif à évaluer et du type d'informations accessibles pour l'évaluateur. Donc, je commencerai par les méthodes basées sur les coûts observables. Donc, c'est les coûts de remplacement ou de restauration d'un bien ou service. Et c'est les méthodes des effets sur la productivité en fonction de production. Donc, les coûts d'observation. Donc, c'est assimiler la valeur du système de service écosystémique aux dépenses qu'il faudrait engager pour le remplacer. Donc, un exemple, c'est les services d'épuration d'eau. Donc, dégradation de l'eau potable d'un bassin versant, par exemple, c'est-à-dire sa valeur, c'est la construction d'une usine de traitement de l'eau. Donc, la restauration du bassin est estimée à, par exemple, donc, pour ce genre de méthode, donc on essaye de voir un peu les scénarios ou les options de remplacement et on définit la valeur par rapport au coût engendré par ce remplacement-là. Les effets sur la productivité, c'est donc l'exemple le plus le plus étudié, c'est le service de pollinisation, c'est-à-dire l'impact de changement du service écosystémique s'il disparaît sur la production de ces biens, sur la production. Donc, l'exemple, une étude qui a été réalisée à l'échelle mondiale en 2009, donc une estimation à 153 milliards d'euros. Donc, c'est ces 153 milliards d'euros, donc ils l'ont estimé par rapport au manque de production qu'il y aurait si la pollinisation, si le service de pollinisation n'est pas fait au niveau de l'agriculture. Donc, deuxième catégorie de méthodes, c'est les méthodes basées sur les préférences révélées. Donc, c'est les coûts de transport, les prix hédoniques et les dépenses de protection. Donc, ces méthodes se basent sur les comportements effectifs des usagers. Donc, tout ce qui est coût de transport, c'est-à-dire que pour bénéficier des différentes valeurs de ces biens et services écosystémiques, donc les personnes se déplacent et ces déplacements donc, engendrent des coûts. Donc, on peut estimer la valeur de ces biens et services à partir de cette méthode, et c'est utilisé surtout pour tout ce qui est usage récréatif. Donc, l'exemple que je donnerai, c'est l'exemple du zoo, par exemple le zoo de Montpellier. Donc, c'est le seul zoo en France qui est gratuit, alors que le coût de fonctionnement de ce zoo-là est de l'ordre de 3 millions d'euros chaque année. Mais l'étude qui a été réalisée en 2004 a démontré que si on laisse le zoo gratuit, donc il a plus de bénéfices pour la collectivité que s'il devient payant. Donc la méthode qui a été utilisée, c'est la méthode du coût de transport. Donc la deuxième méthode, c'est tout ce qui est prix hédonique. Donc la méthode de prix hédonique donc, se base en général sur l'attribution, la détermination de prix par rapport au marché de l'immobilier. Donc, pour les services écosystémiques, donc, on estime la valeur d'un bien qui n'est pas marchand, c'est-à-dire qu'il n'a pas de prix par rapport au marché de l'immobilier. Donc, c'est utiliser tout ce qui est aménité paysagère, services culturels, qualité de l'air, de l'eau et du sol. Donc, l'exemple que je donnerai par rapport au marché de l'immobilier, par rapport à la méthode de prix hédonique, donc, c'est une étude qu'on avait réalisée au sud de la France, c'est-à-dire pour le dédommagement, d'un site résidentiel qui se trouvait à côté d'un aéroport qui a été construit. Donc, c'est-à-dire indemniser, comme on va indemniser ces gens-là par rapport aux nuisances sonores que l'aéroport engendre. Donc, il fallait donner un prix au décibel. Donc, le prix au décibel, donc, le décibel n'est pas marchand, donc il fallait donner un prix au décibel pour pouvoir dommager ces personnes-là. Donc, on avait utilisé la méthode des prix hédoniques qui se base sur le marché immobilier. Donc, cette méthode-là, on ne peut pas l'appliquer au Maroc parce que déjà, le marché immobilier au Maroc n'est pas en concurrence pure et parfaite. Et en général, ce qu'on a démontré là, c'est-à-dire que le décibel, lorsqu'on monte en étage, normalement, le nombre de décibels diminue et aussi tout ce qui est pollution diminue. Donc, le prix au mètre carré, lorsqu'on monte, normalement, il augmente. Le contraire au Maroc. C'est-à-dire le prix, c'est les appartements au premier étage, alors que le contraire, normalement, lorsqu'on monte, il y a plus d'avantages. Donc, le prix du mètre carré, il est divisé sur tout ce qui est orientation et aussi en étage, etc. Donc, on peut par des méthodes économétriques, et c'est de là on a pu extraire le prix des décibels et que ces gens-là ont pu être indemnisés. Donc, tout ce qui est dépenses de prévention, de protection, donc, c'est-à-dire c'est la valeur accordée à l'évitement, à la protection, et c'est la valeur accordée à l'atténuation des nuisances sonores. C'est le cas aussi des dépenses de prévention, c'est aussi le cas des périmètres de protection de captage d'eau. On peut déterminer un peu la valeur de l'eau par rapport aux dépenses qui sont engendrées pour la protection des ressources en eau. Donc, les méthodes basées sur les préférences déclarées, donc c'est les préférences déclarées par les individus. Donc, il y a deux indicateurs. Donc, c'est estimer le consentement à payer ou le consentement à recevoir. Donc, le consentement à payer, c'est l'amélioration environnementale et le consentement à recevoir, c'est tout ce qui est pour un dommage. C'est-à-dire qu'on a un échantillon, une population. Donc, le consentement à payer, c'est-à-dire le consentement de cette population à payer pour protéger une ressource. Par exemple, protéger une espèce, protéger une ressource naturelle. Et le consentement à recevoir, c'est le consentement que les utilisateurs qui polluent, par exemple, ou les chasseurs, etc., sont prêts à recevoir pour diminuer leur activité, pour préserver la biodiversité ou la nature. Donc, les méthodes les plus utilisées, c'est l'évaluation contingente et l'analyse conjointe. Donc, l'évaluation contingente, c'est révéler les préférences des individus en les interrogeant directement sur leur consentement à payer ou consentement à recevoir, on est dans le cas de dommages. Donc, combien seriez-vous prêt à payer pour protéger cette ressource ou cette espèce, ou combien seriez-vous prêt à recevoir comme indemnité ou un dédommagement pour réduire votre activité qui engendre des dommages sur les biens et services écosystémiques. Donc, les types de services, c'est tous les services écosystémiques. Et l'exemple, c'est la valeur d'une espèce, faune ou flore, un habitat, flore, zone humide, etc. Donc là, c'est un exemple d'évaluation contingente, c'est-à-dire pour estimer la valeur économique de la biodiversité des forêts françaises. Donc, c'est des enquêtes téléphoniques auprès de 4426 ménages. Donc, le résultat à peu près, c'est que le consentement à payer de ces ménages-là, il varie entre 45 et 64 euros par ménage par an. Donc, c'est une variation qui se justifie par rapport aux régions sur lesquelles ce travail a été fait. Donc, l'analyse conjointe, c'est à peu près la même chose, mais avec des scénarios. Donc, dans le cas de forêt, par exemple, donc c'est des scénarios d'exploitation. Donc, et on donne ces scénarios d'exploitation aux utilisateurs, aux usagers, et ils définissent leur consentement à payer par rapport à ces scénarios-là. Mais derrière, il y a tout un modèle économétrique pour déterminer un peu la moyenne et le résultat de ces enquêtes-là. Donc là, c'est les valeurs de référence. Donc, j'ai pris le cas de forêt, ce qui est le plus étudié en général. Donc, les valeurs de référence des services forestiers en France, donc tout ce qui est services de prélèvement, services de régulation, services culturels. Donc, le total, c'est environ, donc, la valeur d'un hectare de forêt en France, il se situe en moyenne à 970 euros et une fourchette qui va de 500 à 2000 euros en fonction du site ou des régions des forêts étudiées. Et comme vous voyez, à non évalué, parce que en général, l'analyse, c'est-à-dire que certains services ne sont jamais évalués, c'est-à-dire qu'il y a une difficulté d'information et aussi pour mettre en œuvre ces méthodes-là, il faut beaucoup de budget. Donc, il y a des enquêtes derrière, etc. Et c'est des enquêtes, et en général, c'est des études qui durent sur 1 an, 2 ans. Donc, en conclusion, donc, dans le contexte marqué des changements globaux, c'est-à-dire qui sont sans précédent qu'on vit actuellement, qu'ils soient environnementaux, économiques ou sociaux, donc il est crucial de repenser notre modèle de fonctionnement, c'est-à-dire et de privilégier une gestion équilibrée, une gestion équilibrée qui respecte le fonctionnement naturel et une voie prometteuse. Donc, cela passe par trois points, c'est-à-dire l'anticipation des crises, le renforcement de la résilience et une transition adaptative. Donc, ainsi, la valorisation des services, c'est-à-dire donner la valeur aussi à ces services écosystémiques, devient une clé essentielle non seulement pour préserver la biodiversité, mais aussi pour garantir un avenir durable et aussi un avenir plus résilient. Donc, je terminerai par un écrivain que j'aime bien beaucoup, c'est l'altruisme est la seule réponse pragmatique aux défis du XXe siècle. Et merci beaucoup.
Monsieur Badawi, je ne vais pas annoncer pour les déclencheurs.
So just before starting, I have to make a small recap because we have some chats that some people they didn't understand French. So just to say some words. So the presentation was about how to give an economic value to the biodiversity, to the natural patrimony. So Professor Herbouz, who is a specialist in this field, gave us some methods how to evaluate economically the biodiversity. Among the methods he suggested, the first one is method of replacement. I mean, what it will cost if we have to replace a biological theme that we have and we want to replace it. Second option that Professor Herbouz discussed is the cost of production. And he gives the example of bees. I mean, if bees has to disappear today, for example, and we know that bees are responsible for pollination. So the major part of the trees relied on bees for their production. So we can evaluate the effect of the disappearance of bees on how much we will lose in terms of production, goods or either other thing that we can have from this production. And the last method Professor Herbouz discussed is relying on interviews. I mean, we can ask directly the people how much value you can give, for example, to the presence of such animal or plants here. And from that, we can estimate what is the economical value of that biological patrimony. So that's briefly the method, the economic method that was highlighted by Professor Herbouz. And let's now start some discussion about the themes. So I would like first to welcome again Professor Bazari and Professor Herbouz, and just we can have some discussions, and we can have even questions. If you have, please feel free to ask questions. I may start and waiting to have some questions. So thank you very much. I will start with Professor Bazari. So thank you very much for the very insightful presentations. I would like to mention that Professor Bazari is among the eminent experts in the field of marine biodiversity and marine biology. So we are really privileged to have him with us today. Professor Bazari described the biodiversity in the Mediterranean area. What, of course, interests us is the part of genomics. I mean, how we can use genomics to handle all that biodiversity. And you gave some examples, metabarcotin, okay? You speak about that. I would like first to ask you, according to your experience in the Mediterranean region, those zones that are considered as protected regions. Of course, I suppose, I'm not in the field, but I suppose that sometimes they would now be more protected if the biodiversity is restored, they will be open again. Do we have example in this sense that some protected regions in the Mediterranean area, after the protection, they gain again, though they recuperate the biodiversity status, their normal biodiversity, and they become open again? So that is my first question to you. My second question, I like it very much. I even contributed to work about the metabarcotin and how it gives results more than the traditional fishery. And what could be better? I would like your point of view about that too, because that was qualitative work. Just how many species more we discovered when we used metabarcotin comparatively to the traditional fishery. But imagine that we have quantitative approach. I mean, to know how much from those species we have. And metabarcotin, there are now many works that are trying to use metabarcotin to quantitatively do the work. I mean, know at the same time which species and how much we have. I think that would be useful for you as expert in the field too. So that's my questions for you, Professor.
Thank you, Sibu Abid. Well, regarding the first question, if I well understood, it's about the protection regime in marine protected areas. Yeah, there's some cases like this when, for example, some areas were closed because of some habitat degradation and so on, mainly due to the use of some fishing gears that are destructive to some habitats, mainly erective species. And after many years, they opened it, but with some regulations. You know, you can fish, but not using the same fishing gear and so on. And the idea that I explained before regarding this, the protection, that there's many examples that we consider that closing an area is sufficient for conservation. But in the sustainable development, the humans are in the center of the development. So the exercise now and the experiences are shown that we do it with people, with humans now. The marine protected areas now has changed in the reflection of people because in my own experience, for example, when we started to work in marine protected areas with in Cap Tres Focus in Al Hushaima National Park, then first of all, there was not an acceptability of people, of fishers, the users, because for them, protected means that they cannot work there, they cannot fish, they can't. This is a wrong idea because now marine protected areas has to be a tool for protection, but also a tool for development. And marine protected area in the blue economy, it's a source of a lot of money. For example, instead of and there's a lot of work to do with sensibilization, with vulgarization, because, for example, some species in porc for example, in France, for example, this le mero brun, the dusky brown dusky. There was a lot of sensibilization, and they used something like this, the bioeconomy. They convinced fishermen that instead of fishing one fish, then you can gain, I don't know, 100, 200 euro, and that's it. But if with your boat you bring tourists and they can see this emblematic species, you can win more money during time. So there's this kind of sensibilization. Regarding the second question regarding the metabarcoding, yes, I'm not an expert, but I'm an end user. So if data were quantitative, that would be great because there's many indices, many things that we had with that need quantitative data. But I have to say also about this, in my experience I talked about cryptic species, but also there was some species that we didn't found with metabarcoding in the other sense. But it's normal because in our experimental studies and scientific sampling, we noticed there's some seasonality in the species, the presence of species. So yes, it could be a good tool, but it had to be more controlled with the seasons and so on. So maybe 2 shots are sufficient to have. But as you have seen, it's a promising tool for monitoring, for inventories and many things in marine and coastal ecosystems. And my invitation was that maybe it deserved to some attention for the project, for my colleagues, our students to do this kind of things because I'm not expert, but a lot of on my ecological and evolutionary questions can be resolved with this kind of tools. Thank you.
Thank you very much, Professor Bazairi. Lina, I can ask another question to Professor Hebus. Yeah. So, Professor Hebus, thank you. Thank you. Professeur Hebus, merci beaucoup d'être avec nous et pour la présentation. Donc, c'était très utile de nous parler de toutes les méthodes pour l'évaluation ou bien donner une valeur économique à la biodiversité. Vous avez donné beaucoup d'exemples, c'était facile à suivre, même les personnes qui ne sont pas experts comme moi, prendre un petit peu ce que vous voulez dire. Bien entendu, durant la présentation que j'avais faite pour la bienvenue au début, j'avais dit que, bien entendu, on veut une Afrique développée, mais surtout une Afrique avec le développement économique, une Afrique indépendante et fière de son identité. Et là, j'arrive à ma question, parce que notre identité en tant que Marocain, en tant que Maghrébin, en tant qu'Africain, viennent aussi du paysage qui nous entoure, dans notre pays, du milieu dans lequel on vit. Et bien entendu, moi, par exemple, je viens d'une région montagnarde et je m'identifie avec ça. Et ma question, quand on veut donner une valeur économique à quelque chose qui est concrète, comme les abeilles qui ne vont pas polliniser les arbres, ou bien quelque chose, mais comment on peut donner une valeur économique à l'identité, à la beauté du spectacle, à plein de choses. C'est-à-dire ces choses-là, comment on peut les évaluer parce qu'elles comptent beaucoup à part la valeur économique, comment on peut les inclure de n'importe quelle approche. Et bien sûr, comme on est dans un modèle capitaliste, c'est le dollar qui compte, mais comment on peut donner une valeur monétaire à ces aspects-là?
Merci beaucoup, professeur Badawi. Donc, c'est une question un peu complexe. Donc, c'est-à-dire de donner une valeur économique. Donc, la valeur économique, c'est ce que le bien-être, c'est le changement du bien-être. Donc, mais pour donner une valeur économique à l'identité, à ma connaissance, il n'y a pas de. C'est-à-dire, si on donne cette valeur économique, parce que l'identité, on n'a pas de repère. Même dans la valeur d'usage ou de non-usage, mais on peut lui donner une importance. Donc, pour l'identité ou la culture, vous connaissez tous, par exemple, tout ce qui est les labels pour les produits agricoles, etc. Donc, il y a des labels, ce qu'on appelle la marque ombrelle. La marque ombrelle, c'est de donner une identité à des produits qui sont issus d'une seule région. Il n'y a pas que le produit agricole. Donc, il y a tout ce qui est agriculture, tourisme, artisanat, culturel. Tout ce qui est issu de cette région ou de cette zone-là, il a ce label-là. Et ce label-là lui donne une valeur marché. Mais vous donnez une valeur pour l'identité, j'ai jamais eu de. Oui. Oui, mais il faut. C'est-à-dire qu'on donne la valeur pour des choses qu'on perd. Par exemple, la valeur humaine, le prix, valeur d'un être humain, il y a de la valeur. On peut donner la valeur d'être humain. Donc, ça, c'est utilisé pour les assurances, etc. Et de voir un peu l'espérance de vie, ce que peut l'être humain donner. Ça a été utilisé pour les attentats du 11 septembre, pour dédommager les familles. Donc, en fonction du statut, en fonction de l'espérance de vie de la personne qui a été tuée, etc. Donc, le dédommagement, c'est en fonction de ça. Ce qu'on perd. Et effectivement, si on prend l'identité, on peut l'approcher par ça. C'est-à-dire que, mais ça serait colossal. C'est-à-dire on ne peut pas chiffrer tout. Pas chiffrer tout. Mais c'est une très bonne question. Philosophique, oui.
En France, est-ce qu'on a fait les mêmes ici? Est-ce qu'il y a des valeurs aussi ici et on peut faire tout ça? Oui.
Donc, au Maroc, il y a beaucoup d'études qui ont été réalisées sur tout ce qui est forestier, Marmora par exemple, mais on s'arrête toujours sur les valeurs d'usage, le pâturage, le bois, etc. Donc, on ne va pas très loin. Donc, et aussi de l'évaluation contingente. Le problème de ces méthodes-là, c'est que c'est des méthodes qui nécessitent beaucoup d'argent, beaucoup d'enquêtes. Et en général, c'est dans le cadre de projets de collaboration que les scientifiques, les chercheurs des universités à l'IAV ont fait ces études-là. Mais c'est surtout pour la forêt et pour les ressources, pour l'eau. C'est bien documenté. Mais pour les espèces, etc., à ma connaissance,
Thank you very much, Professor. So if you have any question, please. Question on my phone? My phone, where is my phone? Ah. Because we have some questions from the chat. So this question is either for Professor Bazai or Professor Herbus. They say, what are the main source of pollution contaminants in the bioeconomy and particularly in the sea? And what are current mitigation measures to conserve the sea biodiversity beside the legal frameworks? And the third question, any case studies in this regard of contaminants that pose in risks and impact in declining the marine biodiversity, particularly protecting areas of MS as part of the project? I think it's Professor Bazai. I mean, if there is any case of the contaminants in the marine and that cause the decline of biodiversity, and if there are any special measures in this context.
At this moment, I don't have a concrete example for places where there's contaminants, yes, but from the example I know, yeah, because of their yes, the benthic, because they live close to the floor. Yeah, they are very influenced by perturbation. Let's say pollution or yes, but like all the parts of the sea, there's a risk. There's a risk of contamination because in sea there's, for example, there's some areas that are at high risk. In France, in Morocco, for example, the site that I talked about, that Jebel Moussa, it's a site near the Tangimed port. So the risk exists. So what they have that the Barcelona of Convention have a program that's called MidPol, Mediterranean pollution, and there's many activities, many projects. For one example that I know very well, that Marchica Lagoon on the Mediterranean coast of Morocco was a hotspot of pollution, and with many financial support from Jeff, from Marchica agency. Now it's there was many actions that let this become quite less polluted than many years ago. I think that was the Turkish, no?
We have last questions. I think it's for Herbouz Rashid. It's from Alex Bafana from DRC, Democratic Republic of Côte d'Ivoire. Il dit quel est l'impact du méthode ou bien les méthodes de préférence pour les éléments liés à l'insécurité alimentaire. C'est-à-dire, si j'ai bien compris, les méthodes de préférence pour l'évaluation des phénomènes, bien sûr, de biodiversité, des trucs qui ont un effet sur l'insécurité alimentaire. Comment vous pouvez évaluer ceci? C'est un petit peu la question.
pas si j'ai bien compris la question. Mais pour tout ce qui est l'insécurité alimentaire, donc il y a des indicateurs d'insécurité. Donc, l'insécurité alimentaire, c'est-à-dire que le consommateur n'arrive pas à satisfaire sa consommation, mais il n'y a pas d'évaluation d'impact pour ça. C'est-à-dire que l'évaluation économique, donc, c'est fait pour des biens et services qui n'ont pas de marché. Qui n'ont pas de marché, c'est-à-dire il n'y a pas d'offre et de demande. C'est-à-dire c'est fait pour tout ce qui est services écosystémiques, par exemple euh, la pollution, par exemple l'air, une espèce animale particulière, endémique, comment on peut la préserver, et lui donner une valeur pour que c'est une sorte de plaidoirie pour les politiques publiques aussi, pour diminuer la surexploitation des ressources et aussi encourager la préservation des ressources. Et pour tout ce qui est insécurité alimentaire, c'est d'autres indicateurs, c'est-à-dire c'est des indicateurs de kilocalories par personne, etc. Donc, mais ça ne rentre pas dans l'évaluation.
Thank you very much, Professor. I think we should move on. So I would like to thank warmly Professor Bazari and Professor Herbous for being with us. Thank you very much. So the last question we take, yeah.
Hey, hello everyone. Thank you, Mr. Herbous, for the insightful presentation. And my question is for you. We know that we always face climate changes. And my question is that est-ce que ça influence l'évaluation économique des services écosystémiques? Est-ce que ça influence? Ça veut dire les changements climatiques? Est-ce qu'il y a un impact sur l'évaluation économique des services écosystémiques? C'est ma question.
Merci beaucoup pour votre question. Effectivement, donc le changement climatique, donc, est engendré en grande partie par le réchauffement de la planète. Et ce réchauffement-là, c'est surtout par la séquestration de carbone et les émissions des gaz à effet de serre. Et donc, c'est un cercle. La biodiversité, le déclin de la biodiversité, donc tout ce qui est services écosystémiques qui sont liés à cette biodiversité, c'est-à-dire surtout le système terre, sol, surtout le sol, la forêt, et aussi le système marine, donc engendre ce changement climatique. Donc la valeur, plus le changement climatique augmente, plus la valeur de ces services écosystémiques prend de l'importance. Parce que c'est la rareté. Lorsque ces services-là sont de plus en plus rares, donc par exemple la valeur de la forêt, maintenant, ça c'était une étude qui a été réalisée, je pense, en 2013 ou 2014. Donc la valeur d'un hectare de forêt d'une moyenne de 900 euros. Mais dans 10 ans, c'est-à-dire en 2030, en 2035 par exemple, la valeur, je suis sûr et certain, si on refait la même étude, ça va être plus. Il y aura moins de forêts. Donc, ces services-là auront plus d'importance pour les gens et les gens aussi auront plus de conscience de cette importance-là. Donc, j'espère que j'ai...
Thank you very much. I think now we will have a coffee break. So we invite you to coffee break. But please, we will have just 20 minutes so we can come back and start the following session. Thank you.
le barrage, et pour annuler un barrage. Voilà. Il y a annuler pour la valeur d'une grenouille. Et on dit, oui, on annule le barrage parce que la valeur va être comme ça.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems,
Please. And now, we will start the next session, the third session in this day. Advancing livestock and environmental sustainability, genomics and microbiome innovations. And we have 3 presentations. Professor Badr Benjaloun, Dr. Narjis Shafi'i, and Professor Bulbul Ahmed, who was not able to be with us and was replaced by, I think, Professor Jean from the Mohammed VI University. So I will call Professor Badr Benjaloun to give his talk about the role of neutral and adaptive genome diversity as a potential vector for sustainable improvement of the livestock sector in Morocco, case of small ruminants. Just to say some words about Professor Benjaloun. He's a scientist in livestock genomics at INRA, Morocco, since 2004. He's also a visiting scientist at Laboratoire d'Ecologie Alpine in CNRS, UGA, USMB in France. After his initial postgraduate education as an engineer in agronomy, he achieved his PhD education at University of Grenoble in France. He has been involved and PI in many national and international collaborative initiatives, as well as many European-funded projects. Furthermore, since September 2020, he has been the head of the INRA Regional Center in Beni Mellal, Khanifra, and now he is the head of the INRA Regional Research Center in Rabat. His research has focused on in-depth study of genome-environment relationships. His ongoing work is focusing on the use of various omics technologies for implementing sustainable breeding schemes for small ruminants and chicken. Please, Professor Benjaloun, the floor is yours.
Thank you, Professor Misbah. So it's a pleasure to be with you, to make such a talk here. Thanks, Professor Bouabid, for the invitation. As usual, it's a pleasure. So today, as said by Professor Misbah, I will talk about neutral and adaptive genome diversity as a potential vector for sustainable development of the livestock sector in Morocco. So, okay, try to understand how to learn how it works. Okay, good. So I will start with this slide showing the risk of extension status of the 4 main livestock species, which are cattle, chicken, goats, and sheep. So this figure extracted from the platform DADIS of FAO. It was extracted in April 2024. The situation doesn't change a lot since that time. So the color shows the risk status. The gray are the number of breed, represent the number of breed which are the status of extinction risk is not known, but the black shows the number of breeds that have already been extinct. The red and the orange and the yellow shows the number of breeds for which the extinction status is endangered. The breeds are endangered. And the green part shows the number of breeds for which there is no risk of extinction. So here, what we can see that the number of endangered breeds are more than the number of breeds that are not threatened. So, so we are in a context of a big loss of biodiversity, of diversity in livestock, in these four main livestock species. And the situation it's not different for the other livestock species. We know already, especially here in Morocco, we know that there is a big concern of environmental change with warming and the problem of drought also that we can see in the recent years. And this has been reported in the IPCC reports, and we can see here the problem of drought, and we can deal with this. So livestock as other species or agricultural species are faced to both threats that are loss of biodiversity and climate change. And these make a big challenge for feeding population, feeding humans, and also economy and so on. So we need to have sustainable development plans. And for this, we need to characterize the diversity of genome of the species that we are studying. I think also it's important to understand the link of genotypes to production threats, which was also the case earlier or before. And with the climate change, we need also to understand the association between genotypes and adaptive phenotypes to environmental pressure, which can play an important role in the next year's livestock sector. And lastly, we need also to develop sustainable breeding programs to face these situations. So for this, I will follow the outline that you can see here. I will start with the description of, according to our previous studies, the description of genome neutral diversity in some local breeds. I will show here the case of Morocco and other breeds that are in similar cases. I will show also genomic uniqueness of local breeds. I will show also some genomic selection signatures linked to environmental variation in sheep and goats. I will pass also in review a study that we've conducted about epigenetics marks linked to environmental variation in sheep and goats. And I will end up with some innovative programs for livestock development that we are implementing, we are about to implement here. So I will start with this first component. Here I will show, to understand the context, I will show the domestication of sheep and goats, and also migration wave that have followed the domestication event that had happened about 10,000 years ago. Following this domestication event, domestic sheep and goats have migrated following different migration waves. And this migration, we need to know that it took a few millennia, not it doesn't happen in a few years. I think it was sheep and goats have been spread over North Africa and Europe during millennia, and they get adapted to different environmental conditions and so on. What we need here to know that Morocco, with its geographic position, it's at the end of a migration wave. And generally, with this movement, we can expect that Morocco doesn't have a genetic diversity that is high as much as the diversity that is still in the domestication center, because domestication consists of taking only a part of genetic diversity that is present in wild. And if we would compare domestic animals at the beginning of this migration wave and at the end of this migration wave, theoretically, we would have found a decrease of genetic diversity across this migration row. So we compared in a previous study that has been published in 2018, we compared genetic diversity in domestic animals in Iran, which is the domestication center. We compared also genetic diversity in the wild ancestors that are still present in that area. We compared this with sheep and goats in Morocco, and also a panel of sheep and goats of cosmopolitan breeds that are very widely spread in the world. So what we found, it was very surprising to us. Here we have a metric of genetic diversity, which is the number of private alleles, of private variants, which means that variant, that SNPs, are present only in a population among the 4 groups that we have compared. So as expected, we found that the wild has a very large genetic diversity, the wild ancestor. Here we have in red the domestics in Iran, the green, the domestics in Morocco, and here the light green, the industrial breeds. But it's a panel of absolutely of all the industrial breeds that we can find in the world. So the important thing that here, for example, Moroccan domestics have more private allele than the Iranian domestic. And also here, the genetic diversity in domestic goats in Morocco are comparable in the wild one. And that was very, very surprising. And that shows the important genetic diversity in Moroccan sheep and goats here. And for sure, no comparison between Moroccan sheep and goats and industrial. So industrial that are more present, more prevalent in different farms all over the world have lower genetic diversity than the Moroccan, for example. Here we have the comparison of another metric of genetic diversity, which is nucleotide diversity. And here, for sure, the results translate what we have found with the number of private variants. Here, it's another study. You know, maybe this graphics that shows the past, the variation of the effective population size. The effective population size, it's a metric that shows, if we can see, it doesn't depend on the number of animals that are of a group, but it depends on genetic diversity that is present in that group, not necessarily linked to the number of animals. And thus, those figures shows the evolution of this parameter, of this metric, since the last, since a time in the past. Here we have 100,000 years ago, and here we have the present. And according to the genetic diversity, we can define this evolution of such metric. Here we have the different population, the Moroccan breeds, shown by these lines. Here we have the wild group, and here we have the industrial or the cosmopolitan breed. What we have, we can see here that, yeah, we can define the event of domestication about 10,000 years ago, as we show. And we have this, the wild animals had this large effective population size that have been kept, but in the last millennia, with the degradation of habitats of such wild group, we found this decrease of effective population size. The cosmopolitan one or the industrial breeds have their effective population size decreasing drastically, and we have the lower value of such parameter. But for the domestic, the Moroccan domestics, we have a very high level or very high effective population size. That was interesting and promising for the Moroccan animals. So I will pass here to the second part of my presentation, which is genomic uniqueness of local breeds. I will show you a study that has been published in 2021, and it has been a part of the work of Abdsamad Ourouch. He worked on defining genomic originality or traceability of five main local sheep breeds in Morocco. And he defined many. Here we have for this segment of the chromosome 10, for example, and he found the component of such segment that are defined have been identified as under selection in different breeds. Here I show you this part that has the relaxin gene involved in horns and in fertility in the demand breed. And we found clearly that this breed that is hornless, it doesn't have horns, this component that is specific to that breed. And this was not the case in the other ones. The main breed is known also by its fertility and prolificacy. So he defined at each of the five breeds the main genes that have been involved in the known traits for such breeds. For example, here the breed Benigil, it's known for its meat quality. And he defined, for example, this TTN gene and so on. This is a more ancient study. It was published in 2015, but it shows a good case of this difference between two main breeds, goat breeds, Dar'a and Noir or black goat in Morocco, which have been sampled in the same area known to be very warm and nose dropped events. And we found that these two breeds seem to be adapted to similar in desertic environment through different mechanisms of adaptation. The first one rather uses panting to get adapted, and the second one is using sweeting for adaptation, for such adaptation. I will show you some genomic selection linked to the environmental variation. This study has published in 2024, and we, in such study, we analyzed the genome of sheep and goats of a very large sample of sheep and goats representing all of this part of Morocco, the northern part of Morocco. We sampled those individuals in different area. Each red dot shows an individual that has been sampled. And we sequenced the whole genome, and we tried to analyze, to look if there is an association between this variation of many environmental variables and their genomes. So we defined the genes that have been identified under selection, and we try to get the biological processes that have been enriched with such genes. For example, here I will show the biological process that have been enriched for the adaptation of goats to altitude, to high altitude. What was interesting that we found, for example, this biological process, which is named Clara cell differentiation, which are those cells are lung cells, and they are known to play a crucial role to get adaptation to hypoxia, to low level of oxygen. We found also this process of heart processes, and they are known to be involved in the adaptation to low level of oxygen. I will show just a single snip here. We have the selection signature over the genome of sheep in association with high temperature, with the variation of temperature. And we took a single snip in such peak, for example, and we plotted the genotypes in such single snip over the map of the sampling area. The different colors show the 3 genotypes. It was plotted over a thermo map, a map with the differentiation of temperature, and you can see here the distribution of some genotypes in high temperature areas. In the right, here we have the distribution of allelic frequency over the gradient of temperature. And we see that in such a SNP, we have an allelic frequency of the C, for example, the C allele high at low temperature. And when we get to higher temperature, we move to the allele T. So this study shows the genetic variation and differential DNA methylation to face contrasted climates in small remnants. The work have been published in 2021 also, and it was done by Laure de Noyel. Just to describe this methylation, I don't know if you know this mechanism, but the methylation is something that comes on the top of genetic variation. So it's to explain simply the mechanism is it consists of cytosation of methylation of the cytosine nucleotide in some cases, and it affects gene expression. And we found it really very frequently over the genome. And we tried to get in such mechanism in sheep and goats here. So we compared methylation profile in sheep and goats at low temperature annular range and high temperature annular range in both species. And so we had the expectation to have similar mechanism to try to understand. So what we found, we defined some profile. We found that there is methylation in such genes, but those genes were different between sheep and goats. But such mechanisms have to be more studied in depth in the future, and methylation seems to play a crucial role in to get this adaptation. So I will end up with this, as I told you, I will end up with some programs that were based on the results or the outcome of the previous studies. What are the implications for breeding program of all these studies? So I will show you this first example that is ongoing. The first program consists of making or implementing a genomic selection program in sheep in Morocco. But this genomic selection program is based to increase for sure production traits as any breeding program. But we have the purpose to maintain genetic diversity, but also to increase the adaptation traits. And this is original. This is, among the first programs in the world to try to implement such genomic selection program in such a way. So the idea, I will give you just some details about how we are going to implement such a program. I think Sima will talk about this, or will talk about some results according to this, linked to such study. But the idea is for sure to phenotype individuals. We set up a reference population of 3,000 sheep that are spread over the spreading area, the rearing area of Sardi breed. And we phenotype individuals for sure, but also we phenotype another kind of phenotypes. We try to get body temperature or oxygen saturation in the blood, or heart rates variation phase to ambient temperature. So this is being done through sensor technologies. And the idea is to study the variation of those traits according to the variation of the ambient temperature, and try to see if there are animals that are more adapted or can deal with this high temperature variation and so on. For sure, as any genomic selection program, we are trying to also to make pedigree, genotype individuals. And at the end, we will end up with this genomic prediction of adaptation and production. We hope to get some results, but the initial results are promising. Safa is the main person that who is working on this. The second program is about local poultry. We know that in Morocco, we have such a value chain of local poultry, Beldi chicken, which is very, chicken is very more valuable than conventional chicken. And here we are trying to, we already started and we make such characterization. I think Saida will talk about the outcome of such results, Saida ITZ. The idea is to make a genomic characterization to define the founders of Beldi chicken in Morocco, to make a new value chain of Beldi chicken in Morocco, and to make a program of selection and reproduction. So as I told you, Saida will talk more about this. Here I'm showing to you some results, each dot here in the map shows the chickens that have been sampled, and we compared them with the cosmopolitan one to try to define if we have some originality of Beldi chicken in Morocco compared to the industrial breeds. And the results are promising. I will not say more than this. I will let Saida talk about this tomorrow, maybe. Tomorrow or today, Saida? Tomorrow? Okay. So the idea is to make a national center for build chicken. Okay, as a take-home message, local breeds show very high levels of genetic diversity. And we also can define some genomic traceability. We can see here some genomic marks of adaptation, as we show. We showed also some epigenetics mark of adaptation. And we have to take lessons from these outcomes to define this or to make plans for sustainable development. We have some programs ongoing, but for sure we need more programs to try to get advantage of this genetic diversity to face environmental changes. So this is all. Thank you for your attention.
Thank you very much, Professor Benjeloun. So now we have the choice. Well, let the question at the end of the session, or you can ask Professor Benjeloun just now.
As you want. As you want.
As you want. Maybe
I can get question now.
Yes, maybe this is better. So please, if you have any question, Professor Benjeloun is here. Yes, please.
Yeah, hey, I'm Nargis. I'm a doctor in genomics and quantitative genetics. So one question about when you just plotted how the effective population size have increased for the Moroccan breeds over the years. So I was just wondering, how did that happen? Why? What are the dynamics that made that there was an increase in the effective population size? The second question would be how, because sometimes we would like a little bit of inbreeding so we can improve productivity, but we don't want inbreeding to conserve the diversity. So how can we tackle this trade-off between improving productivity and also maintaining inbreeding at certain levels? Thank you.
So thank you for your questions. For the first question, we know that the effective population size can increase through different processes, evolutionary processes, like gene influx, for example, gene flux and so on. And we suspect that it was a kind of mixing of different breeds, but by that time. And I think also, we think also that gene influx also was with other foreign breeds. I don't know, over the Mediterranean, it was really high level of trading, exchanges, and so on. And I think it was something that, yeah, a mixing of different population. We cannot say this, that it was, they were breeds, because the breed concept is recent. The modern breed concept is about 200 years, and we are talking about millennia. I think, and we can see this also with some archaeological data. There are some previous study, a study here in Morocco that's described the settlement of sheep breeds in Morocco. And they describe this kind of mixture of different and also multiple waves of colonization of Morocco. I think this can be the case, it can be an explanation. About the second question, the trade-off between inbreeding and genetic improvement of traits, I think, you know, you are a quantitative geneticist, and you know that there are many mechanisms to face this, to fix this trade-off, and to try to avoid inbreeding. I think it's, yeah, it can be, yeah, it can be done. We can also go further to try to increase genetic diversity while improving also. I think this is feasible. This is among the main purpose of our breeding program.
Thank you so much, sir, for your delightful presentation. I have a question in terms of climate change and the change that the animals undergo for their diets. How could that pose as an epigenetic factor for the uptake or the downtake of genes that are potentially interesting for breeders? As well as, could you talk to us a little bit about how particular breeding patterns could potentially be an epigenetic threat to the biodiversity of the local breeds that we have in Morocco?
It's a big question. I think, yeah, the relationship between epigenetics and genetics in local adaptation still not clear. And the studies are at a first step. It's an initial step. I think there are many problems, there are many concerns to try to get epigenetic data. It's very challenging. It's not as simple. It's not as simple as for getting genomic data. And I think we need more studies to try to involve epigenetics in breeding strategies or in breeding programs. We are trying to do it by using a simpler way to get epigenetic data, which is Luma techniques. It shows just the number of methylated cytosine over the genome in a population. And we are trying to involve such information in breeding program. I will not say more about this. I can tell you in 2 or 3 years if we succeeded or not, inshallah.
Any other question? Thank you very much.
Thank you,
dear professor. And now we can move to the next talk, which by Dr. Narjis Shafi'i about leveraging genomics and breeding schemes to boost the bioeconomy of livestock in African countries. Just a second, just to present Dr. Narjis Shafi'i. She is an agricultural engineer with a doctorate in animal genetics, genomics, bioinformatics, and biostatistics. Her expertise lies in quantitative genetics and animal genomics with a particular focus on dairy cattle in Morocco. Dr. Shafi'i's research integrates artificial intelligence methods with genomics to enhance the accuracy of genomic predictions while addressing computational challenges. Her work is dedicated to advancing genetics and genomic selection strategies, particularly for Moroccan dairy cattle, with the broader goal of optimizing breeding strategies and contributing to the improvement of livestock productivity in arid and semi-arid regions. Dr. Shafi'i, the floor is yours.
Thank you, Professor, for this wonderful presentation. So I spent a few years working on AI and how to combine it with genomics, but today I chose to talk about how to boost the bioeconomy of livestock in African countries using both genomics and breeding programs. And why are we talking about livestock today? Okay. It's because livestock play a crucial role in African countries. It does not only provide food security, income, employment, manure, transportation, etc., but it also has a social role as it allows households to benefit from common property. It is seen as security and insurance. It also fulfills a lot of social obligations. But, with the population growth and income growth and the increase in urbanization, the demand of animal source food have increased. And so we should increase the production in a sustainable manner to meet this demand. And increasing livestock productivity in African countries generally requires simultaneous interventions in the area of animal feed, animal health, and genetics. And why is that? It's because improving productivity via playing of nutrition through pasture establishment, concentrates importation, etc., will not be sufficient since the indigenous breeds in Africa have low production coefficients. So we should also improve the herd's genetics so we can improve our productivity with the nutrition that we have. And we can do that by establishing a breeding program. And breeding programs can be either a crossbreeding pathway or a selection pathway. And both these pathways should be included in a consistent breeding programs to achieve the objectives. And how to establish this breeding program is by answering two main questions: where to go and how to get there. And these questions can be worked out in a bit more details as what is the breeding objective? So what do we want to achieve at the end of our breeding program? What do we want to change? Then we can ask ourselves, what and who do we measure? What are the traits that we need to measure? How can we measure these traits? Are these traits related to each other? What is the heritability of these traits, etc.? And then we ask ourselves, do we need to use any reproductive technology? Do we need to use AI? Do we need to use embryo transfer is possible? And then we can ask ourselves, what animals should we select? If we're talking about crossbreeding, then which breed I'm going to breed and which animals in each breed am I crossbreeding? And then select the animals that will be the candidate of our selection program. Then after that, we can select animals given all the data that we have with phenotypes, pedigree. We can estimate these breeding values, rank these animals, and then select the best animals to be sires and dams for our next generation. And this is how a breeding program should be. So if a farm is interested in increasing the gross profit margin, then it is recommended that the breeding objective should be increasing the gross margin, not improving productivity, not decreasing costs. And then after we know what do we want, we can see if the traits that we are interested into, if we are improved, if these traits are improved, will they increase productivity? Will they decrease costs? What am I going to do with these traits? And then estimate the heritability, select animals, and of course, we should disseminate the germplasm at the end, because if we don't disseminate the germplasm, we did not achieve a breeding program. So as previously said, a breeding program can consist of a crossbreeding or selection. And crossbreeding pathway is when we crossbreed two breeds. And it was very commonly used, especially for beef cattle, and since the beginning of the 20th century in African countries. And maybe because it was generally conceived that crossbreeding is faster in establishing genetic improvement. And this pathway have two main advantages. The first one is breed complementary, which refers to the fact that we can produce a more desirable offspring that is that combines the attributes of both breeds. So these breeds should be genetically different, but they have complementary attributes. The second advantage would be heterosis. And it is known that the offspring of two breeds can have a little bit better production than the two breeds, but not more than the dominant one. But, however, crossbreeding also has several drawbacks. And the first one is that it is difficult to sustain. So if I'm crossbreeding two breeds, for example, in the terminal crossbreeding, the last product is sold. And so we need to sustain the two breeds, either by purchasing female or either by selecting these breeds. So it's difficult to sustain. And the second one would be genetic dilution. Crossbreeding encountered a lot of criticism due to causing genetic dilution, and this is something that we want to avoid when preserving diversity. Selection pathways, on the other hand, are genetically less erosive, and selection schemes have shown to be impactful in countries all over the world. The selection pathway consists of three main structures. We have the nucleus, a small group of animals that are consistently selected and improved. And then we have the multipliers. They multiply the improved genetics from the nucleus. And then we have the last level is the commercial herds. So they receive the genetic improvements indirectly from the nucleus. They might have some selection at the commercial herds, but they don't need to since they are receiving improved genes. And I wanted to share with y'all as an example of a genetic selection scheme that is very, very known and commonly used for dairy cattle, which is progeny testing. And here in the figure, it illustrates the details of this progeny testing. So we start with a bunch of bulls. They are born, they are candidate of selection, and then we wait at 1 year of age. These bulls are mated with many females so they can produce a large number of progeny. After 3 years, the first evaluation of these bulls occur, and it is based only on reproductive scale. So only bulls with superior reproductive performance are retained for further breeding. The others might be culled or discarded from the selection. Then now we can measure the productivity of the daughters. And then this is a direct evidence of the genetic potential of these bulls. After that, only bulls with daughters with the best performance are selected. And you can see that progeny testing is a long-term program that can take around 5 to 6 years to find the animals that are going to be sires for the next generation. However, in 2001, genomic selection was introduced, and the structure of genomic selection consists of two main populations. So we have the reference population. They are phenotyped and genotyped animals that we are going to use to train the prediction model. So we're going to use the data of these animals to estimate the parameters of the prediction models. And then we have the candidate population. So these animals are genotyped, but they are not phenotyped, or their phenotypes are not ready yet. So we estimate the breeding values of these candidate population using the parameters that we have estimated using the reference population. After that, when we have all the estimated breeding values, we rank these animals, and animals with the best breeding values are selected as sires or dams for the next generation. And you can see here, young bulls with no progeny, they can be used as sires. And this has changed remarkably the breeding schemes of livestock breeding. So if we're talking about genomic selection, we should also see how the genomic selection impacts the genetic gain. And genetic gain is equal to the selection intensity times selection accuracy times the standard deviation of the genetic standard deviation divided by generation interval. So if we assume that this genetic variance is constant, then genomic selection can potentially affect all three of these components at various points. So it can increase selection intensity, decrease generation interval, and increase selection accuracy. So we can increase selection intensity if we select fewer animals. And we already seen that we can use bulls with no progeny as sires. So we have already remarkably decreased the generation interval. However, how can we improve selection accuracy using genomics? Well, we all know if the genetic variance is 100% explained by QTLs, and we have the QTLs, we can achieve an accuracy of 100%, right? But we can't have this information because we don't know the QTLs. So if we can achieve a high LD between SNPs or markers and QTLs responsible for the traits, we can improve remarkably genomic selection accuracy. The second point, which is very interesting, is increasing the size of the reference population. Well, also genotyping females and including them in reference population have been shown to impact remarkably genomic selection accuracy. But we should make sure to not include only elite dams because this will introduce some bias into the genetic evaluation. Also, we have the heritability of the trait. It impacts the accuracy of genomic selection. That's why when establishing a breeding program, it is very crucial to choose traits that can show some gain by selection. And finally, yeah, so decreasing the generation also between the validation and the training population have been shown in many papers that it increases the genomic selection accuracy. And finally, of course, including omics data into the genomic selection can enhance its accuracy by providing additional layers to the biological information. So now that we've known what's genomic selection and how we can improve the accuracy of genomic selection and accelerate rate, so what are the requirements that we need in Africa to establish a genomic selection program? So the first thing is animal and phenotype recording. They are the backbone of any breeding or improvement program. The improvement will be slow if a trait is not measured, and the estimates will be very poor if the pedigree information is sparse. The quantitative breeding. So sophisticated high-dimensional statistical models have been developed to estimate breeding values, and these breeding values are used to estimate, to select the animals. So the choice of the traits distribution, the model to use is very crucial to establish a genomic selection here. Here now we can also talk about AI and how AI can improve the model's accuracy by capturing some patterns that we cannot see with the conventional methods. So we have proper definition of breeding objectives. So breeding objectives for small stock population can differ from breed to breed, farm to farm, country to country. That's why clear definition of breeding objectives and the implementation of efficient systems should form the basis of optimal utilization for genetic resources. Of course, including genomics and epigenetic can increase reliability and appropriate genotypes and production systems. So in Africa, the production systems are very diverse. So we should take this into consideration and should find a way how to see what genotype is better for what production system. And finally, as previously said, subsistence farmers in Africa keep livestock for many reasons other than production. So breeding objectives should include the cultural and social impact of this livestock into consideration, and formulation of these breeding programs should somehow take these dynamics into consideration. The questions that we should ask now, was genomic used in African countries and did it benefit Africa? Well, indeed, genomics have been used and it did benefit African countries in many aspects. First, it can help identify the most appropriate breed or crossbreed for different livestock production systems. An example would be the Kenyan dairy cattle. So they use high-density panel to generate an estimate of ancestral breed composition of animals, and this allowed for the first time accurate information on breed composition to be combined with in situ performance to determine what breed composition worked best for which livestock breeding system. It can also complete pedigree information and correct pedigree errors, which is a problem that we have a lot in developing countries. It can accelerate genetic gain. It enables us to incorporate novel traits such as adaptability, harsh environment, methane emission, etc. And finally, it can help the discovery of gene variants as livestock in Africa are rich resources, and recently many efforts are actually underway to this end. So we cannot talk about impacts if we don't talk about economic impacts, because if genomic is costly, then it's not feasible in developing countries. And also because we should not expect that conclusion from larger population would apply in smaller population, we should investigate this economic impact in smaller population like African ones. So in this paper, the authors tried to assess the economic impact of genomic selection in a smaller population. And so they investigated the economic performance of two alternative small-sized dairy nuclei programs, both progeny testing and genomic selection, over 20 years of investment methods. So they calculated the gross margin as discounted revenues minus discounted costs, and then the revenues as cumulative discounted expression. And as you can see in the figure on the right, the gross margin were actually 3 to 5-fold higher for genomic selection compared to progeny testing. And this is mainly due to the the remarkable decrease in generation interval, because bulls can be culled or discarded once an amount of semen is already taken. So it's actually known that by avoiding progeny testing, bull breeding companies could save up to 92% of their cost. However, some of these savings may be upset by the fact that we need to genotype more animals to improve our reference population. So now that we know that genomic selection actually can benefit African countries, what are the challenges that we are facing that let us not implement genomic selection at this point? So many challenges. We can start by the heterogeneity of livestock farms and systems and farm scales, management practices, lack of sustainable financing, both private and public sector, weak supportive policies and institutional arrangements, low infrastructure, a very good point, the low involvement of farmers in the designing and execution of breeding initiatives, lack of strong technical support for livestock breeding, and finally, limited capacity in the field of animal breeding and reproduction that we hope that we can fix by the end of this project. So the summary of this presentation: selection is a potential pathway for genetic improvement of livestock in African countries, and there is a possibility for successful exploitation of this matter. Breeding objectives should be well-defined and appropriate criteria should be developed to ensure that breeding is effective at a sustainable level. Finally, genomic selection offers a transformative pathway to accelerate genetic gain. However, for African countries with smaller population, enhancing initiatives for genotyping and fostering global collaboration in data collecting and sharing are essential strategies to increase the reliability of genomic selection and long-term sustainability. So I was talking about collaboration, and in data collection and sharing are very essential for increasing the reliability and sustainability of genomic selection in the livestock industry. So I just want to leave this with you, a take-home message: collaboration is key to success. Thank you so much for your attention. I'm open for any questions.
Thank you very much, Dr. Shafi. So I would ask the assistants to. Yes, please.
Good afternoon. Thank you for this beautiful presentation. My question is related to the consequences of breeding. How will it impact the biodiversity? And earlier you spoke about inbreeding, and that was a very interesting aspect. I would like to hear more about it. Thank you so much.
Thank you for your question. This is a very interesting one. Well, of course, whenever we talk about livestock and increasing production, we think that we're impacting biodiversity actually, and we're enhancing inbreeding. But actually, we can do both at the same time. We can both preserve our indigenous breeds, but improve their production. So all the breeds throughout the world and throughout history, they didn't have the production that they have now. So Holstein didn't have like 8 or 10,000 kilograms of milk a long time ago, but they selected this breed. So we can do the same for our indigenous breeds. And if they're giving 1,000 kilograms of milk now, in like 5 or 6 years, we can have more while preserving always biodiversity. That's why I wanted to talk about this aspect of crossbreeding, because what happened in Morocco, when we don't manage crossbreeding, we find in farmers, like local farmers, smallholders, they have some crossbred, but we don't really know the composition, the blood composition of these breeds, because they're using semen that they don't know their origin. They don't know the breed, they don't know what the semen come from. So here, when the breeding program is not well managed and is not consistent,
So we can have these problems. But if it's well established and we know what we're doing, we might, both of them, improve productivity, but also preserve our indigenous breeds. I hope I answered your question. Good.
No more question, please, because we are getting late. So I will ask thank you very much.
Thank you.
For your nice talk, interactivity. I will ask the next. I will ask Dr. Jean Leger. I hope this is it, Leger? Yes. Yes. For the next talk, is Dr. Jean Leger is a microbial ecology specialist. He holds his PhD from the University of Lorraine in France. Now, he is a researcher at the Morocco's African Genome Center. I think it's the Mohammed VI University in Ben Guerir. Okay. And he studies Moroccan plant microbiomes, focusing on their resistance to arid and saline conditions. Please.
Okay, so hello, good evening to everyone. So originally it was Professor Bulbul Ahmed from African Genome Center in UM6P, University Mohammed VI Polytechnic, who was supposed to present. But due to some unfortunate condition, he cannot be here today. So I will present in his place. And okay, there is some parts where I may not be as expert as him, but I will do my best. So the overall topic of this presentation is how microbiome data can be used to foster environmental sustainability in an African context. But first, since African Genome Center is a kind of a recent entity that was recently created, we wanted to present a little bit our entity. So at AGC, African Genome Center, we have 4 main research axes. So the first one is the exploration of genomic biodiversity, which is our main field, both of Professor Bulbul and me. So it's mostly about exploring the microbial communities using tools such as metavar coding, but also the genomic diversity of plants and microbes in Morocco using whole genome techniques and studying the structure and connectivity of populations in the environment. The second axis is more about omics, so omics like transcriptomics, metabolomics, and metabolic engineering. So it is more about a more applied research where we study the different omics of the microbiome. We characterize more the functional possibilities of this microbiome and how to use them, especially in synergy with plants. A third area of research is genome editing. So this one is mainly about enhancing traits of plants through gene editing, using such technologies like CRISPR or the precision targeting of some mutations that cause diseases in plants. And finally, our first axis is natural product chemistry and metabolomics. So it's our biochemistry axis. So it's about the chemical profiling of extracts. So mostly from Moroccan plants and algae, and the assessment of the biological activities of the compounds that are uncovered in this chemical profilings. So we have 9 professors. Our head of team is Professor Mohamed Hijri, that you can see up left. And Professor Bulbul, who was supposed to be here, is up right. And we have 2 scientists, including me, that you can see. We have 4 staff. We have 7 postdoctoral students and so far 6 PhDs, but we expect to hire this year 4 more postdoctoral students and 15 PhDs. So we expect to enlarge a little bit our unit. Okay. So in general, why is it important to study microbiome for environmental sustainability? So at AGC, at least for now, when we talk about microbiome, we mostly talk about soil microbiome. This is really soil and root microbiome. This is really what we study more for now. So as maybe you know, the soil is very, very rich in terms of diversity of bacterial species. If you take 1 gram of soil in some field, for example, you can find an average of 50,000 bacterial species in this soil. And inside this 50,000 bacterial species, you can find an average of 150 millions of genes. And so microbial communities, of course, are key players in ecosystem processes and also in like agro-system processes. So because they are very important for the nutrient cycles of, for example, nitrogen or phosphate. They are also very important in terms of carbon sequestration. And yeah, and if I can add one axis, they are also very important when it comes to resistance, through their association with plants, resistance to drought and salinity conditions. So when we look at the microbiome data sets that are collected on NCBI, we can see, we can see that there is a huge abundance in North America, Europe, and China. And there is really not a lot of data in Africa. So it means that Africa, there is still a lot of work to do. So far, yes, there has been a low productivity of microbiome study in Africa compared to developed countries, which when you relate it to the diversity of African ecosystems, really means that there is a really low balance of studies versus the potential of Africa in terms of microbiome. And of course, it's important to study the genetic diversity of both microbiome, plants, and animal and human populations in Africa to have a global understanding of this environment. So what can be the main problematic to explore when we want to strengthen microbiome studies in Africa? So first, it's important to have coordinated research networks, so to associate the different researchers between the different countries of Africa. Then it's also important to have policy interventions, so to develop plans to focus on innovations in Africa, increase the capacity and the academic programs in our field in Africa, and also, of course, increase the publication output. And also, another very important aspect is to improve the infrastructure development of Africa. Okay, if I can add, so again, I'm replacing Professor Bulbul, but if I'm not wrong, so far the 3 main hubs of genomic research in Africa are Morocco, Egypt, and South Africa. I'm sorry if I didn't mention other countries, but so it's important to develop this infrastructure of genomic research in Africa, which is really not developed so far compared to other continents. What can be done to build the capacity of to study genomics in Africa? So but again, to repeat what I said before, it's important to have a Pan-African effort of collaboration between African countries. It's important to develop trainings and workshops at the regional level of Africa. For example, workshop can be done at the level of North Africa, West Africa, etc., or at the continental level. To develop the curriculum in our field and also to explore the scientific entrepreneurial opportunities to support the bioeconomy of Africa. So if we focus on what we plan to do in terms of courses and training at AGC, so we plan to do training, like in-hand experience of like wet lab training, bioinformatics training, both of our students and through workshops, which would, like I said, both concern the wet labs, the wet lab skills and the dry skills. So dry skills meaning more bioinformatics skills. We also do some journal clubs to help our students develop their skill in scientific discussions. And finally, we plan some courses on statistical studies and also topic-related studies, for example, in microbiome, gene editing, all the different topics that we study at AGC. So to explain what has already been done, so in June 5, from 5 June to 7 June of 2024, we did a workshop for 16 PhD students about environmental microbiome. So from all the lab steps, from so DNA extraction, PCR, library preparation, and then the bioinformatics steps, so quality check, and the analysis of the reads to have like a final analysis of results that can be publishable. We also did so BioGenome Project in October using TrueSeq DNA PCR, and okay, this one yeah, okay, and whole genome. Okay, and this one also, there was a workshop with 16 participants where it was the whole genome sequencing of 96 bacteria, which were isolated, I think, mostly from the Harmala plant in the area surrounding Ben Guerir. And then again, the NGS of the DNA isolated from this plant and the data analysis of the whole genome data. And finally, there was one workshop about the whole genome sequencing of an endemic plant, which was in collaboration with AfricaBP. And there is a publication coming involving both people from AfricaBP and the different people who were involved in this workshop. And I think, yes, this is so this is a publication that was made by AfricaBP, and so I think both Professor Bulbul Ahmed and Mohamed Hijri are involved in this publication. And so here you can see this workshop that I was talking about, so which was about the whole genome sequencing of an endemic plant of Morocco. So there was 10 participants. Which were trained in both the laboratory aspect of whole genome sequencing and the bioinformatics aspects. And the plant that was sequenced was Acacia gumifera, which is a plant, leguminous plant, Fabaceae, endemic to Morocco. And you can see here a photo of this plant. This is the plant that was sequenced. And so tomorrow, actually, we'll begin a workshop on air for biologists, which is organized by AGC. So now I will present some of our microbiome research that is going on at AGC. So one big project is the mapping of the microbial diversity in arid Moroccan ecosystems for sustainable agriculture. So this project is a collaboration between AGC, the OCP Phospho-Boucra Foundation, and ASARI, which is the ASARI Institute in Lyon. So African Sustainable Agricultural Research Institute. So this project is about exploring the microbiome of southern Morocco, so mostly around the region of Lyon, which is an environment that so far was, in terms of microbiome, was, I think, almost not researched at all. So the context is that there is agricultural challenges in this very arid area. There is so of course there is water scarcity, but also there is a high salinity of the soil, which cause significant risks to food security in this area. So the aim was to investigate the native plants which are drought resistant, and especially find some beneficial microorganisms which would have some symbiotic relationships with these plants. And the potential outcome of this project mainly would be to develop microbial solutions that could improve crop productivities in saline and drought-prone areas. So first, the different steps of this project is to identify the key species that associate with these plants in terms of drought and salinity. Study their assemblies, study their variation across gradients of aridity and salinity, and finally make a network, an analysis of networks between these different species to uncover the association between microbial species between them and with the plants, to develop like a combination of microbial inoculants that could be put together to improve the resistance of plants to drought or aridity. So here you can see the different sites that were sampled. So honestly, I don't know the different specificities of each site. I know that Renifis National Park, I think, is a lagoon environment, which is close to the sea. You can also see the region of Boucra. And so the different sites were divided into 5 different ecosystems. So I think, okay, I don't remember what is Grara. I think Grara is like a depression in the soil that can accumulate water sometimes. Dune is a totally arid environment. Sapra, I think, is an area that is connected to the sea and can be sometimes flooded. Lagoon is I mean, it's like a depression that is covered with water and it's separated from the sea by, I think, some amount of sand. And finally, you have the rivers, which can be running or dry. So these different ecosystems were classified according to the aridity levels. So you can see that the most arid is the dune and the less arid is the lagoon. And of course, this gradient of aridity would allow us to see what bacteria or other microorganisms are the most associated with hyperarid and arid environments. And potentially they can be useful then after this for inoculants and to associate with plants. So the sampling was carried in 12 sites so across 34 plants. There is 200 samples of rhizosphere, 200 of roots, 204 samples of endosphere, which would mean, I guess, the shoot of the plants, and 28 bulk soil. So bulk soil, which is soil that is far away from any plant. So the different plants were divided into, so 24% of the sampled plants were trees, 48% were shrubs, and 27% can count as small vegetation. So here you can see the photos of what they did when they sampled there. So on the left, this is Prof. Bulbul and the professor from Asari, his postdoc student and his PhD student, and I mean other people who were involved. Okay, so another project that we have is about the distribution of argan plants in Morocco, and to understand the connection of this distribution with the associated functionality of the microbiome. So, as most of you maybe know, so the argan tree is a tree that is endemic to Morocco. It's a xerophyte thermophilic tree, which means that it tolerates drought and high temperature. It is soil indifferent, so it tolerates a lot of different chemistries of soil, and it can be found up to altitudes of 1,600 meters. The argan tree was classified as an intangible cultural heritage of humanity by UNESCO and World Agricultural Heritage, so by the Food and Agriculture Organization of the United Nations. Of course, argan oil is very valuable. It's edible. It has therapeutic and cosmetic qualities. So in Morocco, there is 3,000 to 4,000 tons of argan oil which are produced annually. And well, this argan tree has some risks to its sustainability in Morocco. So the argan tree were sampled in 4 places, 4 sites in Morocco. So Agadir and Essaouira, which I think are really the classical places where you can find argan tree. But there is also 2 other places, so Arganat in the south of Rabat, of here, and Berkane, which I think are more in the north of Morocco. So we expect, but our hypothesis is that the populations of argan that are found in these isolated places in the north of Morocco would be maybe different from this classical arganre region of Agadir and Essaouira. Okay, so yeah, for example here, so they collected a lot of fruits, argan fruits, and they are, I think now, right now, they are sequencing the bacterial and fungal microbiome of these fruits. And there was also a collection of root and a rhizosphere of argan. And our aim is to, for this, is to not only this time go for metabar coding, which would provide us with an analysis of the microbiome community, but also to use like shotgun genomics, which would give us a functional description of the genes that are present in the root, shoot, or rhizosphere of argan. Sorry. So yes, so you can see that what is planned is metagenomics, which would be both metabarcoding and shotgun that I just explained. And we also want to do transcriptomics. So that is study the gene expression.
Jean?
Yes?
2 minutes, please.
Okay, both in bacteria and in the plant. Yes, okay. And finally, so this is my project. So we investigated the rhizosphere of Malva, which is Rubiza. And something very interesting that we found is that in Rubiza, there is a lot of rhizobium. And Malva is not a leguminous plant. So now I plan to go really forward and study rhizobium in non-leguminous plants in arid areas in Morocco. And yes, and also we found Alternaria and Fusarium fungal species in Malva, which respond to drought. So it can also be interesting, but the most interesting thing is rhizobium for me. And thank you for your attention.
Thank you very much, Dr. Jean Lijay. Yeah. So I've been asked to finish the. No, there will be no question. We will go directly to the discussion of the session, and I will invite the speaker. Just please. Oh, where's this? I will ask also Professor Badawi to join us for some remarks and closing remarks, please.
So I would like first to thank our presenters, Professor Benjeloun, Dr. Shafei, and Dr. Lijay. Welcome. So just we want to have a discussion about this section, okay? So I will have just some small questions, so just that intrigued me, and we can construct on them some discussions. So I will start with Badaw. I was surprised by your result about the diversity of the private alleles that was bigger in the Moroccan breeds compared to the ancestral breeds, mainly in Iran. What I was expecting, I mean, if we measure now the biodiversity in Africa, we'll find it bigger in other countries, in other parts of the world, in Europe, United States, because it was the origin. And my question is, what is your explanation to that? Maybe the first question, according to the simple size that's used for the Moroccan breed and for the Iranian breed, because even the simple size could create a bias on that estimation. If you use more breeds in more animals in Morocco, maybe it will give you more private allele than what was used in Iran. If you use it usually, I mean, that was true if there's a big difference of sample size. If not, what is your explanation to that?
Thanks, dear Bobit, for your question. Yeah, it was surprising also for us. I think it's not a matter of sample size because both sampling of domestics were based on a huge sampling effort trying to get all the individuals representation of all breeds that are present in both countries, Iran and Morocco. But let me clarify something. We didn't get information that genetic diversity in Moroccan domestics is higher than wild ancestors. No, the wilds kept a high level of genetic diversity as expected, but the comparison that was surprising was between domestics in Morocco and Iran. And one explanation could be also the fact that Morocco is at the end of, is located at the end of many migration waves let's say, the North African one, but also we can suspect another wave from the south or from the Sahara and so on. And this can provide a mixing of genes and so on, and an enrichment, a possible enrichment of diversity in Moroccan domestics. Yeah, but the question is open also.
Thank you very much, Professor Benjelloun. Can go ahead or? Yes.
Maybe I'm novice in this area, but I want to ask, what do you mean by the wild ones? Do we have in our country some wild sheep, some wild goats, other than those who are bred?
The answer for this is the domestication of sheep and goats are well documented. So there have been two events of domestication. Both happened in Mesopotamia, in the Fertile Crescent. The first one was at 10,500 years ago, and the second at 10,000 years ago. Both events have captured a diversity of that is present in the wild animals. Fortunately, those wild animals are still present there in the Fertile Crescent. When I was talking about wild, I'm talking about Ovis orientalis for sheep, which is a known species that is present there in Turkey and Iran, not in Morocco, because the wild animals in Morocco, they are not the origin of sheep that we are now, of domestic sheep and domestic goat. But the goats their wild are Igagrus, Capra igagrus. It's a known species that is present there also. Not like, let's say, for dromedary, we don't have the wild ancestor by now. Also for cattle, we don't have the wild cattle. But for sheep and goats, we still have this wild relation.
Thank you very much. I have a question for Dr. Nargis. So according you did very well documented description of the challenges for selection genomic schemes in developing countries. A question, according to your experience, could you imagine modified version of genomic selection for our countries, either from the quantitative point of view or from the structural point of view? Could you imagine some modifications, some inventions to modify this to make it fit our context?
This is a very, how can I describe it, complex question, because it depends on the breed, depends on the species, depends on what the breeding objective that we want to achieve, right? But something that I would start with is that here in Morocco, we have this problem of financing breeding programs. And then I would suggest that maybe a governmental nucleus that will work on the genetic improvement. But first we have maybe to develop our semen storage and semen collection also, because this is something very important in improving any breed, because as we know that males have larger progeny than females. So by just importing, we might not achieve what we want to, especially for whatever indigenous breed we have, for sheep, for whatever. So I would start with that. It should be a small size nucleus because we have smaller population. And then maybe a governmental initiative that will improve the nucleus, and then maybe some multipliers that will have some connections with the commercial. So the commercial herd would also, for example, play the role of the reference population, and then some connection between these three layers. But the biggest problem would be, for me, in my perspective, the first thing is the size of reference population. So if we're achieving just a 20% or 30% accuracy, then maybe pedigree-based is better, right? So if we're going to genotype, we have to achieve a certain accuracy, maybe work on our models or maybe collaborate with many countries to, for example, if we have a population that is in many countries in Africa, we can collaborate and see. For the multi-breed also selection to just increase the number of the animals in reference population, but different breeds is very complicated again, because sometimes, yeah, some SNPs are fixed for one population, they are not for another. So for me, I think this is the main challenges that we should face, is how to increase the reference population to increase accuracy. And the second one would be how to finance this improvement by governmental, and then how to make all the small farmers engage in this initiative, because it's 90% of life. I'm talking about dairy, always talking about dairy, right? So yeah, it's 90% of the farms have less than 5 cows. So we should see how we can engage these. And I think it's by semen storage.
Thank you very much. I have a question for Dr. Lijay. Maybe I'm not in the field, I know nothing, just this question, naive question. Is there any correlation or association between the diversity of the microbiota and the diversity of the species that lives on either plants, maybe normally plants or animals? I mean, could we have any useful information by studying the biodiversity of the microbiota to understand something about species that are living on that soil? Is there any correlation between, just simple example, if I have some plants there, if I found that there is a high biodiversity of some species in the microbiota, that reflect there is high biodiversity in the plant, or there's functional association rather than biodiversity, rather than structural association?
So yes, if I understand your question, yes, there is a correlation between biodiversity of microbiome and biodiversity of plants in general. When you have like a high an environment which is highly stressing for the plants, like very saline and very dry, you will have a low diversity of plants and a low diversity of bacteria, of microbiome in general. And then, I mean, yes, if I understand correctly, what we do in general is like we try to make some statistical association of, so for example, we will sample according to an aridity gradient, like for example, what I showed in around the lion, and then we will see what microbe, bacteria, or fungi are statistically associated to aridity. And then this microbe can potentially be interesting, but just its association with aridity is not enough. You also have to do a functional analysis to see if there is, if there is interesting things that this microbe is doing. Yes.
Actually, this is very complex, very, very complex. There's no direct relationship. In some cases, I would like to say but many people found that in the rhizosphere of the plants, for example, if we take the Ma'mura forest, there are some cork oak trees, and there are some acacia also. It has been introduced, and this is very, very, very bad. You know what? And acacia is invading. Yes, it's invading the forest. You know why? Because it releases some, not seeds, some flavonoids, some oxidate that attracts the best GPRs, the best bacteria, but not the cork oak. Yes, this is very, very bad competition. It's going all over and over and over, etc. There is just an example, but we have also examples for the saline areas also, and you will find that for example, in Senegal, some acacia species that withstand in the saline areas because they attract the best microbiota, rhizobia and PGPR, Pseudomonas, Enterobacter, etc., etc. So this is very, very, very complex, you know. Yes, 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 and everything is yeah, all the dynamics in the soil. Yes, just to Jean, you were talking about the gradient from the aridity from the sand dunes to the lagoons, yes, etc., and the humidity, etc. And did you start working on all these biomes? No, not yet. Already did, or it's in course? Another question. You were talking about Khubiza. And you found rhizobia in the rhizosphere, though. So there is there is no symbiotic relationships, I guess. And the roots, inside the roots, or as endophyte, or it's or in or on, inside. Oh, okay, as endophytes, rhizobia. No new structures, no nodules. Okay, just
yeah, no. So yes, I mean, maybe for people who are not like, so nodules are things, structures in the roots of leguminous plants, which allow the plants to fix nitrogen through the rhizobia bacteria. And now, so I found a lot of rhizobia inside the roots of Khubiza, which is not a leguminous. But my expectation, I studied a little bit literature about plant in arid areas in the world, and I see that there is a lot of rhizobia in the roots a lot of time. So now I'm really going for this project, and my hypothesis, but I don't know, I will try to test this, is that rhizobia participates, helps the plant to create what is called a rhizoschist around the root. So the rhizoschist is like the plant will agglomerate soil particles around the root, which will protect it from aridity. And yeah.
Did you have an idea of the species of rhizobia? Because now rhizobia, some species of agrobacterium are called rhizobium. So rhizobium, the genus, they are in the genus rhizobium. I don't know if you remember. I think you are microbiologists, I guess. Yes, you know the difference between agrobacterium and rhizobium. One is nitrogen fixing, and the other one is not nitrogen fixing. But at the 16S level, they are similar. So many of agrobacterium were transferred to rhizobium according to the 16S phylogenes, and so on. I don't know if these are real rhizobia or just agrobacteria. I don't know. I'm asking, I don't know. It's the first time I knew about that. I know that there are some bacteria were nitrogen fixed located inside as endophytes inside the roots, for example, of the sugar cane, Gluconobacter, etc. They are fixing nitrogen, but there is no new structure in the roots, but they are located they are agglomerated in some places in the roots, and they fix nitrogen and they give nitrogen to there is no new structure, no nodule. I don't know if this is a similar case.
Well, it's probably a similar case, but yeah, so far I just did descriptive community studies, so I cannot say if rhizobium is really helping the plant or not. I will test this in the future. It's like I'm kind of betting on this, but who knows? Maybe I'm wrong. and between agrobacterium and rhizobium. So yeah, even if these bacteria are really agrobacterium, still I'm expecting that they are helping the plant somehow. And especially when I compared with other literature, I see a lot of this genus inside. So yeah, and but I'm not expecting nitrogen fixation actually. It's not. I'm not focusing on this. Yeah.
Some Tunisian teams worked a lot on this. I think to the colleagues from Borsadria, Technopole, they work a lot on the agrobacteria inside the roots and even inside the nodules, and they help. They have some functions in the plant. It's what it keeps them. I'm sorry, we monopolized the.
Oh, good. Thank you for this rich discussion. There is any question? So this case, I have to give very short conclusion remark because I'm charged up in the program. So just, this section was about how we can use biodiversity for the understanding of the evolution and adaptation of the animal species, as highlighted by Professor Badr. He even gave an example about how one genotype, one allele, could be associated to the adaptation to temperature. Also, we can use the biodiversity to improve animal production, as the genome selection scheme suggested by Nargis, and also the biodiversity studied by the microbial community to understand and scrutinize the ecosystems and understand how they work functionally. So I would like again to thank our professors, Professor Benjeloun, Dr. Shafi, Dr. Lige, and our Professor Misbah. And I would like to ask each one of you. Thank you very much and see you tomorrow.
Ah, mais moi, je suis vraiment enthousiasmé par ça. Moi, je suis parti.